The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone and welcome. My name is Nathan, otherwise known as Old Man Builds. Today we're going to be talking a little bit about transistors and how it works on the shell of the outside of a UFO. Guys, it's a cool subject here. Basically what we're going to get into is the actual elements that are going on. So what do you want to use? What do you not want to use? And there's a reason why all the aircrafts that fell or UFOs that we think are out there that came down have a certain pattern to them. And let's just start with the obvious. We have aluminum, bismuth, and then aluminum. And there's a good reason for that. If you look at it as a capacitor, you could basically put energy in the aluminum side like they normally would. It then hits the bismuth, and bismuth is either in one of two states at that point. It's either in a liquid state or it's in a solid state. If it's in a solid state, it basically acts like lead with a certain additive to it. If it's in a liquid state, it acts mostly like liquid mercury. So you get two different effects because of the temperature of bismuth when it melts. So as soon as you put this thing on, you're going to get a different effect than if it was just sitting still. So you have to address both. Now, they deal with this in transistors a lot. When you look at things and how they saturate things and which metals they want to use. Originally, they were looking at putting metals on the outside and then putting a metal on the inside with a very low temperature reading. So you could put it very low in there and it would saturate and flow through the field, right? And it came down to something where they started adding in the words electrons. This is the fun part, okay? And it makes it harder to understand, to be honest with you, because they say electrons and holes, right? So what are you trying to do? Get the electron to the hole. Okay, that's it. Saturate it. It basically came down to saturation anyway. Think about it like this. You take the base of your transistor and it puts out a field. When it puts out that field, you have your source and your drain, right? And then it's basically going to connect them based on the amount of saturation that comes down in the energy. So what is this like? If you take high voltage and you basically want to spark it over, and it's too far of a distance, just put a screwdriver in the middle of it. What does it do? It attaches on this side, then goes over and attaches to this side, right? So you have basically the field being created so it goes right through. Now understand that when they deal with this in the saturation level. They could say electrons and holes all they want, but this makes it more confusing. All you're doing by doing this is putting out an energy field. As soon as that energy field hits one side or the other, it starts to make the energy flow. That's as simple as they get when it gets to a transistor. You put enough energy in this one, it saturates, builds out the field so that it touches the source and the drain and it's able to flow. Okay? That's not that hard. That's easy to figure out. Now, which side do you want to go? You want to push amperage through it? That's an NPN. You want to pull electricity through it, which is a PNP. They're built differently and for different reasons. But it all depends on the layers that you put into it. So say we want to do this, but we don't want it to react right away. Well, then you would put an oxide layer into it. So you'd use aluminum oxide in there and as one of the layers, which is very interesting to use in itself. You think, oh man, aluminum oxide should amplify it. Well, it may if you get to a certain temperature and it'll change. But otherwise, it resists everything that comes around it. So you have to be able to use the metals properly in order to do this. They use silicon in there because it goes really fast, but they need silicon oxide to make it work better. In saying that, what is it that you're looking for? Well, a crystal is the easiest thing to understand. It's a time device. You basically tap it, tap it, tap back, right? But it also builds out heat in the field. So as soon as you get heat into it, it saturates the field. So if you want to get from one area on one side to the next, you need a saturated field. That's what they don't tell you in there. They like to bring up electrons and holes, which is fine, but it's not going to help you in understanding something when you get to a higher voltage or understand why you're getting bleeding, why you're getting leaching going on, and stuff like that. These things have to run fast. They have to be able to turn on and turn off, turn on and turn off, right? If you run an amperage through the field, you put in a little bit of voltage, guess what? Boom. Immediately pulls the amperage right to the field. But it also brings a tremendous amount of heat. So your NPN is not going to run as smoothly as your PNP. And it has to do very much with because you're pushing that amp through it. You're not pulling electricity through it. When you get to your PNP, you are literally pulling the electricity through it. The electricity is a colder field than the amperage field. So it stays cooler. When it stays cooler, it operates better. When it operates better, you get a higher yield. So when you look at the two and you put it in there, I use a PNP in my Slayer exciter, right? I can push it at 40 volts all day and it has a monster field. If I put it on an NPN, I got to drop the amount of power going in. I got to drop it down to like 25 to 30. And why? It's because the transistor itself heats up. I cannot keep it cool enough, even with a fan on it, to keep it in proper operating temperature. So it is able to work less. That's what sucks about pushing amps through these fields. So how does that tie in now that we understand what we're doing in your transistor? How is this tying into a UFO craft? Well, when you get in the atmosphere, we have atmospheric energy. We run a corona motor, right? Basically, when we get up there, you have voltage out there. We call it potential voltage because it's not AC. It's technically just potential, right? So you have that out there, but how do you use that to your advantage? Well, on the outside of the craft, you have to be able to pull it in like a PNP. You want to pull the voltage through the system. In order to do that, you have to run it like a PNP. And you look at transistors and you look at these crafts, transistors themselves is a boosting device. It boosts the energy coming through. Why? Because you're having fields of saturation in there, which means that you're putting more energy in there than you think you are. Then it boosts the energy coming out. So it gives it, like when you talk about a radio or AT&T in their phone, basically they use it to boost the signal so that they can hear people better on the phone. That was the original purpose of the transistor. But that also works in a UFO craft. So if I want to boost the energy coming in, I'm already getting free energy, right? If it's out there pushing a amperage field, then I'm not going to get what I'm looking for here. I am going to get the wrong thing because I'm not pulling in amperage from the upper atmosphere. I'm pulling in voltage. So the NPN is out. You've got to use a PNP type circuit. So what do you want the outside of your craft to be? You basically want the outside of the craft to be like a transistor. You want to be able to pull that energy in, but you want it to go through certain layers because oversaturation is bad. Things turning on when you don't want them on is bad. How each product works with the next one. So if you want a specialized effect, you got to use certain things, and they build them all in the same way, guys. This is not something that's not in the scientific realm. You're going to find that every time you find one of these downed UFOs, the actual metals that are in there are the same things that are using in your transistors. Does it mean that the transistors are falling from the sky? No. It means that they used the outside craft as a transistor in order to get the effects they wanted. They use that to pull in the energy that it produces. You see, this is a constant field that's building. And if you understand the Tesla coil and the cold energy as a pump, and how you pump the earth, it makes a lot of sense, right? You're pulling in the energy from the earth. You have it grounded at first, okay? Not on the Tesla coil itself, but if you use a gravity fly or something like that, that's grounded. It pulls in the energy into a field. It pumps it full of energy, okay? Then you have a floating ground, and then it continues to pump in the energy just like that, just like a PNP does. So you get up in the upper atmosphere, you're going to be pulling in energy the same way. So you have to build your actual systems on the outside to flow the exact same way as a PNP does. With that said, exotic materials, why would you want to use them? Why wouldn't you? Well, if you want to use something like a carbon, right? And you want to use graphene, why would you want to use it? It's because of the speed that it gives you in electricity. It moves faster than silicone does. So you're able to push that field so much faster through this. It also has a secondary effect. As you put it in lattice form like this on the outside of your craft, what does it do? Because it's working with the same energy and pulling in the energy from the atmosphere sees it as a like energy. As soon as it sees it that way, it immediately recognizes it and does not put up a mock barrier. That's the reason to do it. You're reducing the pressure against the plane as soon as you put it in there because you're pulling in the energy. You're pulling it into the craft. You're using that energy. So it reduces the amount of mock you get against your craft, which removes some of the inertia from going on. If you can use a transistor to amplify that, guess what happens? Then the amount is reduced even further until you get to the point of zero. Then you have no inertia. That's the reason you would want to do this stuff in there. One of the other elements that shows up in there is cobalt. And let's just look at cobalt for what it is. If you put it in temperature wise where it becomes superconductive, and it does become superconductive, it is far less than most metals out there. So it's an easy superconductivity. Why would you want that in there? Well, you want to amplify things, don't you? You want this stuff to be able to create more energy than what you're actually pulling in. Well, that's how you do it. You get it superconductive. When you get a superconductor, it's changing the way it works with the energy around it in the environment. That's why you want to do it. You see, a lot of us out here have already created devices where you can pull in the outside energy from the field, right? You can pull in the energy from the room. For those who haven't, I'm sorry, but you're going to have to learn that. Why would you want it to be cobalt? Because it's a superconductor at a very, very decent temperature you can reach. It's not something you have to continuously blast, okay? It's something that where it gets out there to like the atmosphere of space, then you're going to be able to use this thing. With that said, now we get the extra value additive to it. We get that amplification effect that goes much higher because it's working on a different principle. So a lot of these things, man, you're going to find that they're all in the same thing. When you start to look at transistors and stuff, you start to understand this. Which metals do I want to use? Why do they work together? Why do I have to have oxides in order to cover stuff? What's the thin barriers about? Why does this old man keep telling us it's saturation instead of electrons and holes? And it comes down to a very easy understanding. They first had a gate that went on the transistor, right? And it sat on the very top. And as it pushed down, the source and the drain connected, right? Pretty easy. That's easy stuff. What was the purpose of doing gate all around? So then they take the gate and they put it like a horseshoe right over everything else, right? Right over the source and the drain. Why? What was the thought process going on there? Well, they'll tell you the electrons and the holes. What it actually was the saturation rate. So it goes in from both sides like this, plus it comes down from the top now, where before it was only coming down from the top. Again, a transistor is about how fast you can switch it. If I saturate the field with just this, it'll take a while to get it to switch, right? Again, these things are really small. But if I go with this and this, guess what they found? It was an immediate switching at lower power. Why? Because this only has to penetrate so far, along with this penetrating so far. So what did they do next? Gate all around. What does that mean? It means basically that gate goes 360 degrees around this whole thing. They learned that saturation was the key. Again, they still call it electrons and holes, but what's the actual answer? It went from this direction, and this direction. So what happened? It saturated the field faster, put all the energy into it faster so that it can run through the source and the drain faster. That's a pretty easy way to see it, but it also turns off faster because you're not taking one field that's trying to break into this big bar right here and then saturate the entire thing, that would take a while, and it takes a while to turn off. But if you come in from every angle at it, now you're being able to turn it off and on immediately. So what happened? We have a jump in technology because we were able to saturate and desaturate the field very fast. That's what's interesting about it. That's why they switched. So now we put that over to our UFO. We definitely want that in there, don't we? We want to be able to turn it on, turn it off really fast. We want a conversion rate. I always talk about conversion and stuff because conversion of fields is so important. If you know which field you're in, you know which one you can convert to and what you need. In understanding a transistor, it's the same way. I am going to convert a field in here, but I need to do it as fast as I can to switch it on and then switch it off. I don't want it on forever. I just need it on for a few seconds, and that's it. Boom. Turn it on, turn it off. Just like that. You do not want to continuously run that same secondary field. Why? Because if you're in a field bubble in itself, right, and you change that field, say I'm in a radiant field and then I want to go to a magnetic field. Well, that's not just that hard. You just got to saturate it with a magnetic force, right? As soon as you do that, you flip the field. But what's the problem? You cannot sustain this the anti-gravity of the craft in doing that. You have to flip it back right away. You need the propulsion from it, but you immediately need it to shut off, okay, and go back to the original way to do it. So flipping a transistor with a gate all around makes more sense. Now I can flip it like this, boom, 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 and get it to go as fast as I want to right away and get it to go in one direction right away. That's why you would use this technology on a craft shell. It's all about the saturation rate and how fast you could do it. But you probably wouldn't learn this unless you knew that you're flipping fields. You see, it depends on where you're at. They always tell you anti-gravity and the bifield Brown effect is 3 weak fields, but they come together to make a strong field. Why is that? This is where people get lost. I'm telling you, it's static and magnetic. Okay, what does that mean? They're on a DC. They're on the same scale. It just means how many amps are in the system. Okay, if I have very little amps, it's in static. If I have a lot of amps, it's in magnetic. That's about as simple as it gets, right? But what happens when I reduce the amount of static and I reduce the amount of magnetics? Well, the field has to break out somewhere. The energy has to go somewhere. It doesn't dissipate. The energy breaks out in a radiant field. It breaks out all around it. It's just a volume of energy. That's all it is at that point. Now you can understand the 3 fields you must switch in. They say it's a gravity field along with magnetic and static. It's not gravity. Gravity is only created when you have the radiant portion in there. And then the gravity itself is the effect of all 3. It's not a field in itself. That's what people misunderstand. They always talk about a gravity wave. Well, if you don't understand the fields, how are you talking about a gravity wave? Do you even know what it is? So most likely it's just RF, and you're moving between the RF layers. It's not really gravity field. It's an effect of energy, not electricity. It's effective energy. So you're also going to get a temperature differential in there. Okay, you're also going to get a frequency difference. I mean, these things are all predictable. They're 100% predictable. So I'll say this. When they build these things out, there's a very specific reason they're doing it. In using this, they're taking advantage of every single metal and why they're built. That's what they're doing. They're not messing with it. They're not playing with it. They're building it for a very specific reason. They want to switch the field fast, and they know exactly which one they're in. They learned this a long time ago. People are still arguing because the math works. See, that's the thing. You go, well, there's a gravity field. There's gravity wave. It works in the math. Yeah, I'm aware of that. I'm very aware of that. But I can write RF right there and it still works. You see, that's the problem with it. You do the math, does it actually work in the science? Can you create a gravity wave? Well, if you take your transverse and your longitudinal and you create a pulse and an impulse, yes, you can. But that's the same way you create RF. You see, do you understand what I'm trying to get to here? It's the same thing. You're just not noticing the field because you have no idea which field is which. If you don't recognize the radiant field, you'll never understand this. You'll never get it. You look at the northern lights. We literally see the RF. We literally see it. Okay? There's no getting around it. You literally see the waves. And then you go, oh, well, what is it doing? Well, it's flipping the field right there at that point over at the top of the world. It's basically telling you, hey, I am going right now from a radiant pure energy out. I'm going more to a magnetic. And as soon as I add that magnetism in there, the RF breaks out. And you start seeing it in the northern lights. And you're going, man, this looks magnificent. Look at all the waves. Look at the energy, non-energy, right? And you're going, this is fantastic. Well, that's RF, guys. That's the way that it works. And that's the way that it builds out. So you know you're flipping the field. You know that there was a different field before you got to that point because you understood how to change it. So is it a gravity wave? Not really. I mean, technically you could say yes, but you technically have to say RF would be as well. And it's the additive words. When you get to physics, you have to put in certain words for certain things. So you have to come up with a new word because you can't use the same word twice. Whatever. When it builds out, it builds out. We can see it. We understand it. We don't have to add extra words to try to make it sound more complicated than it actually is. This is why you understand transistors and how they work. I need to understand material science in order to understand why they would do it. Gate all around. Okay? Simple understanding. Do we use a wire or do we use like a mostly square wire? Okay, there's a difference. Which one do you want? They have different effects. And if you didn't know that, you need to go back and run the test again. They have two different effects that are going on there based on the amount of saturation. And why? Because you're changing the level of electricity and amperage in there. You're changing the volts and amps in every system. And when you're in DC, it's a very predictable way it goes. And if you don't understand it, you should really start to figure this out because it'll work on every single test that you do to show it. As you bring up the frequency, the voltage goes up, the amperage goes down, the temperature goes down. When you do it in reverse, if I bring the amperage up, my temperature goes up, my frequency goes down, and my voltage goes down. It is as predictable as the sun coming over the horizon, guys. It happens every single time in one of these fields. That's how they can precisely tell you exactly which one they want to use for source drain, and they can exactly tell you which one they want to use for your base. Okay? That's how they know that. That's how they calculate those values. Now, because it's on a high K value that they went to, this is when they came out with the Pentium 4. They went to a high K value inside there instead of a low K value. When they switched that, now we get into the TT Brown capacitor. Why in the world would they want an electret in this? Well, because it's faster, because it's not pushing the amp. You see, when you push amps, you're pushing heat. You don't want to push heat. Again, we just talked about a DC system. As soon as you add amperage, you're adding heat. You don't want that. You want voltage. You want it to pass through easily and faster. Predictable as a DC system, man. It's hard to explain this if you don't understand that. Okay? Why would I want different materials in there? It's the same reason you want bismuth in there. Everybody talks about it, but they rarely understand it. They go, well, it's in crystalline form, so it makes the crystal has a high magnetic value. Okay. That's at low temperatures. That's cool. High temperature, what happens? It melts. You have too many amps in there, bismuth is the wrong metal because it melts. But maybe that's the effect that you wanted. But it changes the value of the effect. You see, cobalt works the same way. If I can keep it as cold as possible with electricity flowing through it at all times, then the heat level goes down, but it gets a crazy effect that happens. The actual temperature in it goes so low that things start to freeze over. As things start to freeze over, guess what happens? The cobalt becomes a superconductor in the system. Now we have exponential expansion of energy. Now we have superconductivity. Do you understand what I'm getting at here? That we had to look into the material science of transistors. That's where it is. It's not just in the outside of the UFO, it is actually in stuff we build today. Please understand this. They probably have 3 or 4 things that they gave to DARPA before we even knew it was going on that they haven't released to the public. Because you got to remember, the transistor industry is probably 10 years behind where it should be, at least. And they do that because they want to build out everything in that same way that they do it for cost, so that they work in the same way. So they have very minute changes they do to it, give you a small gain. But in their research facilities, they have stuff that gives you a very large gain, but they're not giving it to you or me. They're giving it to DARPA. They're giving it to the government. They are literally not giving it to us. They give all that experimental stuff to them, so they are way ahead of us. In some cases, they have figured this stuff out probably from the Germans right after the war, and they started implementing it. What does that mean? It means that we're probably 50 years behind them. Maybe in the world of technology, it would probably be about 200 years behind them. So, and that's because they have when they put it out versus when they have it. And we're way, way behind where the government is on it. So they've already figured out the superconductivity. They figured out the effect. They figured out which one flows with which. They understood the fact that they put this stuff on their planes, right? They put a mesh field over there on their planes, and then they get this thing to reduce the amount of energy needed to push through a Mach barrier. So it's actually pulling it in. We already knew that this effect was happening as soon as Tesla in the, what is it, the 30s or 40s came out with the Tesla turbine. Why did it fail? Because the aluminum itself couldn't put up with the Mach speed that it wanted to run at. What did he need? He needed something to put on the outside. He needed to dope the outside with a field so that it wouldn't destroy itself in Mach. That's why the Tesla turbine failed. So if I went out here and put graphene on the outside of the aluminum, then what would happen? The actual amount of energy on the outside of it that it creates of the electricity or the potential on it would make it flow faster, but it wouldn't mess with the aluminum and taking it out of where it needed to be. It wouldn't warp it, you know what I mean, destroy it, things like that. But that's exactly what they learned when they did these aircraft. They learned that they needed to coat the outside. There was a famous Asian scientist who was out there working on anti-gravity projects, and she was doing the same thing. She's out there putting mesh on the outside. Why? Because of the same effect. If you put graphene on the outside when you're up in the atmosphere, what happens? If electricity flows through graphene faster, what happens to it when the outside field is completely electric and it's voltage? It's an untamed voltage. That's why they call it potential. But what happens? It flows over it. It sees it as a like. It doesn't see it as a disturbance in the area. It sees it as, hey, you're one of us, come along with us, let's go in the field. So now that we understand this part of it, we understand why the UFOs start to use different things, right? Now we're getting to the point where we look at it and go, okay, not only do we know switching, we know saturation of fields, we know that they're bringing in an extra energy. In order to get this thing where it has zero inertia, that craft on the outside has to have a blazing field of it, of voltage, doesn't it? Funny thing about when you work on this gravity fire that you find out. Keep saying it, and I'll say it till I'm blue in the face, okay? You're creating a field on the outside, but the field is held in, okay? You're in magnetic, plasma, and on the inside you have voltage, okay? It builds out as radiant. It's all right there. If I saturate the inside with voltage, what's going on? Well, I'm creating a tremendous amount of energy over the top of my craft already. But the field itself is not a shell on the outside, is it? You see, it's open air. That makes a huge difference because now I can interact with the environment at will. Now, as I contain the energy in it, there's energy passing through and amplifying through it. Now I get more energy than what I thought I did. It's the same reason you put one of these things on the ground. Yeah, I can't stress enough what that means. You have to put your gravity flyer on the ground because the Tesla coil is an actual pump. Your Tesla coil is not grounded. It never was. People ground it, they ruin the effect. Your grounding comes from the actual craft itself. It's what pulls in the energy to build the field, and it builds it in increments on the inside and the voltage and the outside and the magnetics. It's building both in order to create that plasma layer, and then it's a very thin see-through plasma layer that you create, and it's able to push in, pull, like pump in the energy, just sucks it in, man. It's like we've seen it in all the tests I've done with this Tesla coil. It's doing the same thing. It's not lying to you. But that's kind of the thing, isn't it? So when you get up in the atmosphere, you want to do the same thing. So you're actually pulling in the energy from the atmosphere. So therefore, you have to have a transitional bubble that will allow you to do that. It cannot be a hard surface. But when you get to the surface of your craft, you need the energy to flow faster. You need that layer to be faster. Let's go a little further into this. We can make the craft stronger if we change the outside and how it works. You say, well, how do you do that? Well, we have to look at things in structures and how they're built. If you're building a lattice structure on the outside, right, and you're crossing the things, so you got like this, right? It looks just like this. You're building that lattice structure out there. It goes down to how you build a diamond, okay? And just understand this. When you want to break everything apart in the earth, right? And you need a high amount of carbon and you surround everything with magma, right? As soon as you do that, it starts to break apart. It's basically taking all the materials and breaking them apart, right? And then the frequency that goes on inside that chamber right there is what sets it for being a diamond or quartz or whatever it wants to be. Is a simple frequency in there, but it's a repeating frequency. It goes again and again and again and again. All the time, the same frequency, okay? This is why it has to be understood this way. So now you get that. One side of it's breaking it apart. The frequency itself is putting it back together in the shape that you want. Now, frequency equals 1 over time, so it basically tells you the distance and the amount of time it takes to get there. But did you also know that it creates it in distance? The frequency equals energy over distance. Now you can predict the length of each one of those things that you have to create. And it's based on the size that you want that actual lattice structure to be, bigger or smaller, right? So now that we know that, we can decide exactly how we want the outside of the craft to be. How do we know this? It has to do with the magnetron itself. They use in diamonds, they use a magnetron and they shoot things with microwaves in order to get them to change the structure or harden the actual diamond. What are they doing? When they hit it with that, they're bringing the same frequency again and again and again and again and again. That's the heart of a magnetron. It is set up with those little pieces of metal all the way around it. But every time you take one of those pieces of metal all the way around it, you actually make a geometry structure inside of it. The actual distance, the time, the frequency, everything is set. So when they're hitting it, they're probably taking that spacing in between each one of these points that are in there. So if you say that the oxygen point here, 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 all they're doing is going faster so that they can shrink the amount of distance in there because the F equals 1 over T. They're shrinking it, but also frequency equals energy over distance. So now they're shrinking the amount of time in between it, right? So now they're making that lattice structure stronger. As they make the lattice structure stronger, what happens to diamond? It makes it harder. When it makes it harder, now it can produce energy faster when you have a diamond, just like the blue diamond. That's what they're doing. So on the outside of a craft, you're going to get the same effect. That's what you're looking for. Now this stuff can be as flimsy as it wants to be on the outside, But as soon as that energy hits it, it's harder than steel. I mean, think about that. It's harder than titanium, but it can be flimsy as a weather balloon. It has to do with how you excite the lattice structure on the outside. I mean, think about that. That is absolutely magnificent understanding. They're changing the lattice structure based on the amount of electricity going through it at any one time. It'll harden stronger than titanium. And because the energy flows over top of it in the atmosphere, it breezes right through things. This is something that's not normal for people to understand. You have to look into every one of these material sciences to find this. It comes down to, did you do your homework on the transistor? Did you look at the materials? Did you see which one does what? Did you see why they work together? Did you understand how you can take diamonds apart and build them together? Bernie's got the coolest thing in the world, man. He makes his ormus, right? And what is that like? Well, if you wanted to break down the carbon in order to make the diamond, you basically take the elements in the earth and you're going to break them down into individual parts. Well, the ormus has already done that. So now if I don't want it to be carbon as a structure, say I want to use bismuth and silver as my structure material, right? Well, I now have to just take the ormus and now I put it in there with the microwave and the frequency, right? And I'm able to restructure that into my lattice structure on the outside. See, that's a huge understanding. That means that you didn't need the heat of that volcano in order to destructure everything and then put it back together. You basically need the understanding of how to make ormus. You needed a very small amount of electricity and water for electrolysis. Why is that important? All over the world right now, guys, they're finding out that under our ocean is an ocean twice the size of it. Everywhere. They're not finding magma. Okay? For those of you out here who are still on the old model of magma, this magma mantle, this core is magma, all this is magma. We got all this magma around, right? It's a surprise we don't sink into the center of the earth, right? So ridiculous. It's water and rock. That's what it is. It builds out as water and rock. They're exciting the water in a different way. You see, this is why the understanding of the center of the Tesla coil is so important. When you see it going into water, you see that field building out like crazy. But what if the core of the planet builds out that way? Well, it goes right through water and it makes water an amplification device. Total different understanding of how it works. The Egyptians got it right. The Egyptians flowed with nature. We flow against nature a lot with the technology we have. We really do. The Egyptians understood it. They built their pyramids based on this stuff, guys. They understood this type of energy. This is why you want to go cut rock, you want to go cut the granite, right? Put this type of energy in the water, saturate that piece of granite with that energy, right? Now take your piece of metal, right, and go over with the two hand things and cut it. I guarantee you it'll be faster and easier. Because as soon as you do this already when it's dry, you're already creating sparks, right? But when you have energy in there as well, you're creating like 10 times the amount of energy in there that sparks out. That's an EDM machine. That basically is cutting right to the stone easily, just like an EDM cuts through metal, like super easy. It's the same effect, but it has to do with which energy state you were in. They understood it. It's the same thing that has to do with the plants there. When they put this into their plants, they get a different protein spike than what we get. That's why if you look at the blue lotus, it has a different protein spike when they pull it up in the tombs than we have now. It's not an anomaly. It's just the way their energy worked around their building. It was their technology. It was completely different than ours. You look at the light bulb, okay? And you go, oh man, they do this light bulb right here on the hieroglyph, and we know it's a light bulb, right? Well, what is it doing? It's doing the same thing as your Tesla coil is doing. It's using it as a pump to ground, just like your light bulb does to the ground. It's grounding out that thing. So it shows what looks like a flower. Flower would normally be associated with the ground, right? And then they put it on this little pillar. Well, the pillar's doing the same thing as your Tesla coil is doing. It's pulling the energy in the opposite direction than you think it is. That's how that thing's lighting. And it comes down to another understanding that people always talk about. You go, man, I was in this tomb and I had my camera out. And it seemed like when I took this picture and I was standing there, the energy came out of my camera and it sucked all the energy out, and my camera never worked the same ever again. Man, do you know how many times that happens to me in my garage? As soon as I get around this Tesla coil, what happens? If I'm pulling that field, the energy in my battery drains immediately. You see, it's not the same thing as they keep talking about through all these videos. Oh my God, the Tesla car, it put an energy in your phone. You know what I mean? No. This energy will pull it directly out of there. Why? Because it's pulling energy out of the surrounding area. If you're in the tomb, you're in the surrounding area. If you have batteries, it immediately pulls it out. That's why that effect's going on in there, because there's a little bit of it still running. It's the understanding of that light bulb, man. They knew it. But you have to transfer your thinking of AC and DC to energy. You have to see energy as what it is, not what they want you to think it is. If these people had their way, they would tell you all day AC and DC is the only energy available in the earth. Well, we know that's a lie. We know that's a lie. Radiation in itself is an energy form. Piezoelectricity is an energy form. Did you ever think that they work together? The piezo itself is your timing, right? Tap it back, tap it back. It's your oscillation that goes on, right? It is your resonance that goes on in it. The radiant portion is how it builds out. That's it. When you compress the radiant portion, what do you get? You get radiation. There's no misnomers about that. I just irradiated myself. Look, I was over here with my Tesla coil and I put another Tesla coil in it, and I was showing you guys the actual fields that were going on. There are a few people that actually caught on to what I was doing. I was using the radiation field of that in order to drive those lights to get more energy into them. I was literally sitting in a radiation field. For those of you who understand that, man, good for you. You guys got it. It's why they do it. Evan Brock does this cool thing, man, where he uses Tesla's energy right to the center of the coil, puts it into what it is, a bulb, basically, when it comes down to it, or you call it an X-ray bulb, okay? And what does it do? It creates cold electricity X-rays. Tesla did that. He built that. So when Evan does that, right? Evan Brock goes out there and does this, and he shows it to you. You know it's creating radiation. You knew it as soon as he did it. You don't get an X-ray without radiation, okay? You just don't. You ought to have it in some form or another. But what is it? Why is it radiation? Because you compress the living daylights out of it. I mean, I don't know if you understand that. You're literally compressing the field inside your Tesla coil, man. You are pushing that energy to the center. You are creating radiation. When you get into the gravity fire and you look at anti-gravity, right? What are you looking for? You're looking for your nuclear moment. Well, there it is. You are creating 100% radiation when you create this field and you put it in pressure. Now you have your nuclear moment. I don't know if you call it nuclear. I'd call it more radiation, because you're going to get radiation out of it. God knows I did. My hands tell me that I did. That's for sure. Anyway, it's a material science thing, guys, is why we got to really start to understand this. And it has to do with coatings and stuff like that too. I mean, did you ever think when you look at the gravity fire, and Charlie, I know you're out there, they had that coating there over the top of it. The oxide coating on the aluminum. Did you know that's the exact thing that they use in a transistor? Why? Because it stops the voltage from going through it. So if I take a disc that's in, say, static electricity on the top, and I'm rotating it, right? And I know I kill the field as soon as I let it spark. What do I want to do? I want to coat the top of that center plate. If I coat the top of that center plate, what happens? I'm now creating the same transistor effect. I'm not allowing that voltage to go through, but I'm allowing it to just turn around and build in a field. and it's slinging it everywhere, man. I'm building that field. It's exactly what he was doing. That's how he first started it. I think that's how he learned of that whole effect. It was a transistor right there. Guys, there's a lot to learn with all this stuff. And like I said, material science can become a much bigger part of it than you think it is. And if you just follow the transistor field, we can get there today on building this stuff. We don't need the next experimental stuff because we're not ready to amplify it yet. We're just not. We haven't even figured out the field bubble yet. I mean, I have. I doubt many people have ever seen it. They don't understand it like I do. They think it's some mirage, something that this old man made up in his head. Well, when I can take it and consistently amplify the energy on the inside of this thing, there's no mirage there. Okay? Your oscilloscope does not lie to you like that. It's going to show the energy pickup. But it's like anything else. If you try to put it in too fast, so you go, man, I could just use this Van de Graaff machine and I can throw as much static as I possibly can in there, right? That's got to do it. That's got to do it. Well, it'll put a lot of static in there, that's for sure. But what happened? You overdo the barrier on the outside. You see, your magnetic's got to hold it in. So you think about it and you say, oh man, then it's got to be those magnets, right? No, it's not. Now, though, they create eddy current in the center plate. The magnetization you're looking for is in the DC flyback itself. The core of the DC flyback is magnetic. It is pulled out of there as the negative in your coil. So guess where your magnetic field comes from? Right there. Right there. That's where it was the whole time. It interacts with the Tesla coil field because the Tesla coil field's neutral. When you compress it like that, it's a neutral field. It acts like nothing until you interact with it, and then it converts it. So you're getting a field that builds out in radiation. So it's got to be compressed in the center, which it is. And Alexei showed that in his red light experiment. But the outside of it's also quite large. About a 3-foot field that goes around this thing, man. So when you start creating that, and I've showed that in testing, I've shown that field pull way, way out. Okay. There's no question it doesn't. And most people go, man, I can't get my Tesla coil to light my gravity flyer more than a few inches from it, right? How the hell is this old man pulling 3 feet out of it? It's because I understood there was a field there, and I showed it very clearly. When you understand that, you also understand this. The rate that you fill it matters. If you put too much static in at one time, it jumps the magnetic field and then blows out, and your whole room becomes statically charged, which is the worst experience in the world. If you build them together, the energy propagates together. So as the outside field strengthens, the inside field pulls more energy, and the plasma barrier grows. That's the understanding here. You cannot put too much in one. It has to start at a very low volume and build up. Okay? Build up, build up, build up. Static builds like this. It starts to build as like a pressure wave. Okay? It comes out like this and starts to build. Well, as soon as it gets out to a certain point when there's enough around it, he turns on his Tesla coil. And then boom, it immediately holds it in. Now we're equalizing the value. Now we're getting to the point where we have all of it. We've immediately, boom, put the field on it. Okay? And it's immediately now causing this energy to be forced in there. It can't go anywhere. It's interesting in how this works. The piezo is it's really a pain in the butt, is what it is. When you know the two effects that you need, and you know, I blew out 2 hearing aids with this thing already because it does go ultrasonic on you. Okay, for those of you who think it doesn't, it does. And for those of you who think you need 1 megahertz in order to lift this thing, well, that may be true, but where does the megahertz frequency comes from? I mean, think about this. Where does it come from? It's all in the amount of voltage that you could put into it. If you're literally filling this thing with voltage because you're not turning off the tap, you're not shutting off the fountain here, okay? It's continuously flowing. So as you're doing that, the amount of energy goes up. The piezo is more like a mirror to all of the energy in there. than what you conventionally think. Because you think, oh man, piezo kilohertz as much as it can go, can't go to megahertz. Well, as soon as I turn it on, it goes to megahertz. It goes to 25 megahertz immediately. What do you see when you have the field built? It creeps up and up and up and up. What is that telling you? The amount of energy that goes on inside that field is creeping up. It's not going anywhere. I still got my foot on the gas. I'm still putting as much into it as I can, but it's not going anywhere. It's not dissipating. It continues to grow. Okay? It's like one of these, what do they call it, ball lightning effects, where it continues to grow in the inside as the frequency starts to go up. That's why he builds it that way. That's why my hearing aid gets blown out. Okay? Immediately when I hit the button. But what does it also do when I hit the button? It makes a tinking sound. You know where that tinking sound comes from? Every time I hit it, it's not the piezo popping, because that's not the effect it's going to do. You're not pushing energy through it like that. You're turning it off. So think about it. You hit a speaker against something that's flexible, a diaphragm. The diaphragm, if the speaker's here, the diaphragm moves like this, right? So what happens when you turn the speaker off? The diaphragm straightens out, right? But if I turn the speaker on, the diaphragm bends again. When I turn it off, it goes back. So what's the effect? The effect is that tinking sound is that center plate pushing back up. When it does that, you're taking the negative from the bottom of the plate and putting it on top. If you understand lifters, there's two types. And if you just think it's ion wind, man, you got a lot to learn. You're taking the effect, and here's how it works, okay? 99% of the time, the small disc, okay, goes to the big disc. Why? Because you're taking a positive, okay, and you're putting it down there and forcing it down there so it wants to attract to it, right? Well, when you flip the field on the bottom on the big disc, what does it do? It makes the big disc now want to go to the small disc. So you say, well, anti-gravity, man, you put it on a scale. If you just put it on a scale, man, just put this thing on a scale and see the reduction. Well, that's a big pile of horse shit. It doesn't work that way. It works by changing that field. As soon as you change that field, the amount of weight in the craft doesn't matter because you're pulling it, because it's constantly like a dog trying to chase its tail. It's trying to get to that small disc and it can't do it. Okay? As much as it tries, it can't get there. Okay? So it takes the amount of the entire craft of weight, pulls it to that little point. I mean, I can't tell you how much that's misunderstood in everything. Even people that deal with statics, they don't generally understand why they get that misnomer in their test. They do it and they go, oh man, this works great, it's worked great. Oh man, we got an opposite effect. You ever try to explore that opposite effect and find out why? Well, that's why. See, you know, Alexa came out with this device, man, and it looked funny. It had these little antennas, and it's got two light bulbs on it, a green one and a red one. What do you think they were for? Now, times people tell me it's a static tester, right? We're just testing the static level. What are they for? Think about the two fields I just told you that were there. You have a static field, and you have a magnetic field. What the hell do you think you're looking for? I mean, think about it. That's what you're looking for. That's what those two lights are all about. That's, hey, indication we are set with our field and we're ready to go. We built our bubble. That's exactly what he's telling you. Hello, hi, we're here. We built our bubble. If they don't go off, guess what? You didn't build it. It's sometimes hard to get those things to go off. Why? Because you didn't build it properly. You tried to jump the event. You tried to put too much static in it at once, and it's just going into the center plate. It's trying to saturate that center plate where you never convert the field. Okay? Anyway, that's the understanding of that machine, man. You can, is there a way to trick that thing without using a piezo? Yes, there is. Okay, there's two ways potentially to do it. And I'll just tell you this and we'll be done with that. If you know that it's creating the negative on the bottom and you want to put the negative at the top, what do you need? You just need wire laid out on the top part of it, right? That has no value to it. You put no value to it whatsoever. But you do take that negative that comes off of your bottom of your DC flyback and you put an on and off switch on it and you put it right to that wire. You keep it on off. When you want to pop it, you turn it on real quick and then turn it back off. And you'll pop it. Okay? The other way to look at this is if the energy, and it does both things, so just understand this. When you pull two plates apart, it creates a massive vacuum. Well, when you create the vacuum, what are you doing? You're pulling in the energy from the surrounding area. When you're pulling in the energy from the surrounding area, just like a spark gap does, okay? You're creating a vacuum to the inside. When you create that vacuum to the inside, what happened? You could take 9 volts. As soon as you pull it apart, it's 1,000 volts, right? All of the potential energy in there, again, we're not using it and burning it off, so it stays there. We're pushing it into one point, and we're creating a massive, massive amount of energy being pulled out of there at one point in time. Again, the Tesla coil is neutral, so it gives you all of that energy as soon as you break that open. So what would be the second thing you could do? You could just go over there and take a solenoid, or 3 of them, put them on the top, and have this whole plate down, right? And then hit the solenoid button and pull that thing apart immediately. And you can see if you can't get it to pop that way. Those are 2 ways to pop that field, okay? But the way he did it was the piezo buzzer. He took the plate, pushed it down, and brought it up. Do I think that the actual solenoid and that little wire on the top would be great to work in conjunction with each other? Yes. Yes, I do. I think that there's a timing effect that goes on there that you would need both. That's why he didn't do it that way. That's why he used the piezo instead, because he found he can get the same effect. Yeah. There's a lot of stuff in here, guys, that's pretty much material science in that gravity fire that's an absolute fact. It's there. All of it's there. All of it. I watched Todd Desiato 3 years ago talk about how this thing worked. He was right on. He just got the magnetic field wrong and where it came from. You see, a magnet's, when you shell a magnet in an iron, okay, or a steel, what happens to it? Well, it diminishes the value. So in those things, all those magnets are shelled. So where does it go? It only goes one direction. It's the only side of the magnet's open. It cannot produce a field outside of that on the shelled side. That's what they're for. That's the way they're built in science. You cannot get that field to rotate like you want it to and create that big field around it that has the effect that goes like this. It doesn't work. That's why you would take the negative of the DC flyback and put it there, because it's a magnetic field. That's where it came from. That's what gave you your magnetic value. He was 100% right in how that thing worked, man. Right down to the radiation part of it. He got all of it. And the math worked. Just difference in where the parts actually came from and why they did what they did. You literally had to smash a DC flyback to find that. You weren't going to find it any other way, because the description on it is absolutely horrible compared to what the device actually is. So anyway, I'll be done talking about that guy. That's just kind of the thing, though. And I'll say this just to finalize the transistor thing, and we'll get into all the comments, guys, and see what you guys think. If you want to just take 3 videos in there, man, get the ones that don't talk about all the electrons, okay? There was a great channel out there. Let me see if I can't say the name of it. It is, matter of fact, let me share it. This channel right here, guys, put it up in the comments. Watch the videos on transistors, okay? I guarantee you it'll spark in your head if you understand all of the materials used. It'll floor you. And if you guys watch APAC yesterday, um, you had Jared on there, and he showed you the chart of exactly what's in these UFO crafts, right on the outside of it. And it's very important to look at that and just take that chart with you and have it pulled up, and then watch these videos, and just take your little pencil and check them off. Just check off which ones are there. Then go back and look in the video exactly why they used them. I think you're going to get like mind blown when as soon as you do that. And they go into the bismuth on that channel as well. They do not go into the cobalt, but I think most of us can figure that one out if we just Google it and you see what temperature cobalt becomes superconductive at. But it tells you everything else. So, yeah, it's an understanding of the craft, understanding why it's doing what it's doing, and what you're looking for, and the reasons why you're looking for it. I'll tell you this: in that in the gravity flyer, if you built an outside, just say aluminum foil over the top of it, would it work the same? Well, yes and no. Would it hold in the static? Yes. Would it be able to put the magnetic on the outside? Would it work as the barrier itself as the plasma would be? Yes. Is it going to be as effective as it would in open air? No, it's not. It's not built for that. It's literally a field generator that has an anti-gravity effect to it. It's built the wrong way. You want to build a field generator, it's a perfect device. It has anti-gravity properties because of what it does. Anyway, that's like 2 cents on it. So, all right, guys, see where we're at. Yeah. By the way, that magnet thing, yeah, there was a great channel out there. I can't remember the name of it. It's older gentleman out there, and he shows these huge magnets, by the way. They're like this, big giant brick magnets. And he's telling you how to reduce the effect on them on certain areas so that you can put these things together. And he starts taking iron wire and wrapping it, right? And as he wraps it, it's reducing the value of the magnetics. So it's interesting to understand that simple factor in that and why they're in there. They were just there to reinforce the eddy current in the center of the plate because it's part of that pushback effect, right? You can never go positive. When you push that piezo down, it'll try to make the whole plate positive if those magnets aren't there strong enough. See, that eddy current effect keeps it where it can't go and change that field from the negative it's in to a positive. It always has to stay negative. That's why I call it a floating ground. It always has to stay negative. It should never go positive. That's a failure. So, oh man. Displace, not dissipate. Yeah, right there. Let's see. Cobalt transition from hot to cold. First look. Yeah, I'm going to tell you right there, man. That's an amazing thing to look at when you look at cobalt. You imagine that in a motor, man, and you just cool it down a little bit. Ooh, would that be nice? Yeah. Oscillator from the center point. There you go. Elijah knows what's going on here. Let's see. Bismuth wow, that's some stuff that you haven't seen in a structure in one. Equilibrium with the atmosphere. The most dielectric substance known to man is matrix structure. Use cobalt in slot car motors. Nice. Okay, got a question here. What do you think about lifting a rock by reducing the weight? I think ancient knew something like this. Okay. Wow. All right, you got to look at the effects that are going on. So you look at the ancient monks, right? And they produce an anti-gravity effect with the rock. A couple things to understand. It's in a bowl. Okay. What do you get in a bowl when you take your finger and put it in water and you put it at the top of the bowl? Like this. You start to get a resonance, right? You're getting a resonance going on. So what happens when you sit over there and you put a bunch of music into it? Well, you're getting a resonance built up, but you got two horns. Okay. Two sets of different horns. Okay. You understand that? You have a drum beat. Okay. I have the same thing I have in any lifting craft. I have a frequency and resonance. I have another frequency and resonance. Now I got a pulse. Okay. I have a resident frequency. I have the highest amount of frequency I can possibly get. That in itself breaks nature's field. Then it's basically like a slingshot. Okay. You say, or a catapult, I should say. You say, man, this rock goes like this up. Yeah, well, it's a catapult effect because you're basically taking this thing now where you created this thing that's no longer attached to nature itself because you broke gravity with that. And once you know you broke gravity with that, at some point that bowl fills up with electricity, right? Because you got something vibrating like this, right? As soon as you create the vibration, it's like going down the hall in your socks. What does it do? It creates static. Okay? That rubbing, that whole friction creates static. When it gets to too high of a value, boom, it shoots off. Yeah, they knew something more about it than what we did because they used nature itself, but they also used sound that came out in the correct way. We used speakers to create sound. Well, at a certain decibel level, the speakers shut off. They don't create the full energy. You see, repetition in how things oscillate together is how things break things. That's why, okay, horses on a bridge, people on a bridge, that you can't have this many people walking across the bridge at this time. Okay, you can have cars drive all day long, but why can't you have people? Why does it mess it up when I have horses going across the bridge? They're not like horses. What's going on? Are they prejudiced against a horse? No, not at all. It's the two different hooves. As each one comes up and down, it creates frequencies between them, and it's consistent. It's not like they're stopping; they're continuing to go. You know what I mean? Across the bridge. Well, how does that screw that up? Well, you hit the resonance frequency of the bridge, it distorts in nature. It can't handle it. It'll vibrate itself to death until it breaks itself. You've seen these bridges sway like this, man. These things that we would never, dude, you could never move that thing. You couldn't take the biggest truck you could find and move that thing. This thing is massive in size. Why the heck is it screwing up in nature? It has to do with the resonance. Resonance screws things up. You look at Tesla's earthquake machine, does the same thing. It's the resonance over the time. You say, oh man, earthquake machine, it puts out frequencies. Well, it's putting out two frequencies, okay? You got to remember they're an oscillation. So it's one's on, and then it's off, and then it's on. It's the same thing in your Tesla coil, right? It's resonant to each other. Well, it's going up and down. So you got two separate ones going on. So you have two frequencies in oscillation on top and bottom. What do you also have going on? You have water hammer and steam hammer going on the bottom of that thing, right? It's that pulse. It's that pulse that pushes it. See, you think pulse, it pushes a little bit, right? But the next time it pushes a little bit more. Then pushes a little more because it's looking for saturation. It's trying to saturate all that metal, and then it starts vibrating the metal because it's in saturation, okay? It's the same effect. It's going on and on and on, and we're just not paying attention to it. We're not connecting the dots here and seeing what's going on. Same thing in a Viamana. You have four pipes in a Viamana. Two of them are at this height. Two of them are at this height. Okay? What goes on in them? These two create an oscillation between each other. These two create an oscillation between each other, right? But they create a beat frequency. What's a beat frequency? It's the pulse. When they have the pulse, it's a resonant frequency, right? So we understand what it is. Now, here's a challenge for you. Go over to the UFO hieroglyph in Egypt. And we all know which one it is. I want you to take all that crap that you keep talking about, okay? All that, the helicopter, the UFO, the airplane that looks like a UFO, the tank that you guys think is there, okay? You think of the comet that's in there and the lunar shard, right? All this stuff, right? Get rid of all of it. Erase it. What's on the bottom left-hand corner? It's a resonant frequency. Once you understand that, you understand what they were doing. They knew about it. They told you about it. You got preoccupied with looking at a UFO. Got caught with the eye candy, right? Well, I wasn't caught by the eye candy. Look at what they did. But right before that, they told you a story. They told you the plant. Okay? Looks like a couple of little weeds, right? They showed you the Egyptian cross. And then on the other side, they showed B. And you go, why the hell would they show you B's? It's because bees are attracted to resonance. The Egyptian cross is a symbol for resonance, and resonance itself, when you put it into plants, plants grow faster. You get a good crop yield out of it. Now you can understand it. They set it up, then they told you about it. And then they told you the effect of it, which is a UFO. Some people say, oh, well, it was changed. It was changed in, whatever, time it was changed. Okay, well, that might be true, but why did they change it to that? Even if your time frame could be right and they changed it, when they changed it, were we any closer to be beyond, swords made of brass or something like that? Or, copper or whatever? The answer was no. No, we weren't. Okay? We're maybe in the Iron Age or something like that, but not anywhere close to now. Not anywhere close to now. Why did they change it? Did they need to tell us something? Things are predictable, man. You have to look at things for what they are, not what you want them to be. And another fun fact, when you get into resonance and you go to the Mexico temple, and they have this thing that has to do with bees over there in the hieroglyphs all the time. People get all weird about it. Why are they talking about bees? Because bees are attracted to resonance. Resonance is the key to gravity. That's why I tell you, when it builds out in RF, what am I doing? I'm breaking what feels like radiant field, okay? So let's think about it this way. If I told you RF was this thing that went across like this, and it had these wavy lines, right? Which it does. You see it build out in AC Tesla coils all the time when they zap stuff. Not a problem, right? What if I told you that radiant was just, those things are still there. They're just so close together, your eyeball can't tell the difference. What if that's all it is? Your eyeballs can't tell the difference if they're there or not. They're so small. So what are you doing in nature? You're trying to get in between them. I said, well, why would you want to get in between them? That doesn't make any sense. Well, it does. Look at the levitation device. How's it built out? The same exact way. There's a zone that the little styrofoam ball can sit in. There's a zone it can't sit in. There's a zone it can sit in. There's a zone it can't sit in. Okay, are we getting it? Okay, you're building out the RF in it. Guys, we're not talking about anything different. You are literally using speakers, okay? You're not getting away from the magnetic and static field. You're getting ready. You have oscillation going on in there in the speaker. You have two magnetic fields going on, okay? Speakers not hard to figure out how they're built. They build them out of styrofoam plates, for God's sakes, with little wires. It's all right there. It's not changing anything. It's just telling you what it's doing. What does that actual shape look like when you do it? This is the funnier thing. It's ironic, actually. What does that shape look like? Well, kind of like UFO. Why would you build a UFO in the way that you do like a disc? Because it builds out like that when you go look at the fields, how they intertwine each other and you go like this. Why? Well, it's because how it builds out. If I'm trying to jump from one field to the next, the next, the next, what am I doing? I'm working on scalar, right? I am simply going, okay, I know I have this frequency at this distance, but as I get here, it'll dissipate the frequency at this distance, and it'll dissipate the frequency and energy at this difference, which means my temperature in the different areas is different, right? I'm literally building out scalar in order to jump this thing, okay? And I'm going from this field to this field to this field to this field to this field. And you're going, really? That's really all it is? Is this stuff literally builds out that way, and then I'm jumping in between each one of them? Well, yeah. Byfield Brown told you that. That effect told you exactly that same thing. I'm not making it up, guys. They told you it. They just, when they start talking about the K value, you better be able to understand a transistor and why they have low K values and high K values. You better get into electric research and understand why they have high K values there, which, by the way, mesh is the greatest thing on earth for a electric. Let's just be honest about it. That whole thing, man, it's changing the way everything is. So if you look at a magnetic field and you put it up to a piece of iron, right? You're trying to change the directions of each pole that's in there, right? Because they're all scattered every which way. So what you're doing with the magnet is you're changing all one way so that it has a value that builds out, right? Well, that's all you're doing on electric. So when you put the aluminum foil over it, they're aligned. When you take the aluminum foil off, they go misaligned. So why would I want mesh? Well, I want mesh because I want the alignment, but I also want the field effect. So I would need something that has both a coverage value, but also has an open value to it. So now I can create the alignment all the time in creating that energy flowing all the time, but then I can have an open air value. And then how do you see that? It's in microphones. When you have an electret and a microphone, it works the exact same way. I mean, it's all right there. I know it goes into a lot of different fields, but did you think anti-gravity was going to be easy? You think you just turn it on one day? You go out and, you know what I mean, take a couple of colanders, put them over top of each other, throw a couple of fans in there, and we had this thing flying? No. There's a lot of information you have to have, a ton of it actually, in order to get any of this stuff to work together. Yes, I agree with you on that. Let me just put this up. Somebody needs to finish the periodic table. I think it all comes in due time, man. Once they figure out how these things build out and they get the real understanding of it, frequency equals energy over distance, I think you're going to find that that whole periodic table will become easier than you think it is to build out the rest of the way. And I'll leave it at that. You guys can use your imagination and why. But yeah. Oh, what's up, Charlie? Remember, you told me UFOs use organic plasma for anti-gravity. Does organic plasma mean anything to you? Only in the fact that it uses the same energies as the Earth. You're literally pulling those energies into the Earth when you're taking your gravity flyer and have it on the ground. You're pumping in the field of the Earth. And think about it. We've shown on this channel where you take the ground, you put it into ground, right? And it pulls the energy to the device. It doesn't push it out to the ground and ground it. It pulls it in. So if you're organic to the plasma field, then you're dealing with the nature itself produced, right? So the only way that makes sense to me is that you pulled in the energy from the actual ground itself, which means you pulled the energy of the Earth. Once the energy of the Earth is matched and we're no longer dealing with all of DC electrics, now we're in the right field. That's why in the future you're going to see a lot of this stuff, man. Even right now in transistors, you see the silicon in there because silicon is part of the oscillation of this whole Earth structure. But the energy is different itself from a DC field. See, DC field is man-made, and the Earth has a different energy. So if he's telling you it's organic, it's got to be because you're pulling in the energy of the Earth itself. That's my opinion on it, and that's basically the way we've seen it pull in, man. Organic is basically, did you not put any pesticides on it? Well, organic in this manner means, is it created by the Earth? The only way to get it into your system, and it does, is by using the Tesla coil as a pump. See, that's why the Tesla coil itself is not grounded, but the craft is grounded. Because you're using the ground of the craft in order to pull the energy into. Okay? The pump is just pulling it, right? But it's pulling it into a capacitor. It's pulling the energy from the ground into a capacitance field, right? And it's never making it back to the Tesla coil. If you've ever seen this stuff, you've noticed that. You don't ground out your Tesla coil. You leave it where it's ungrounded. You leave the gravity flyer on the ground. It pulls it into a capacitance. In that capacitance is where it stays. It can't make it back to the Tesla coil. That's what I would call organic energy. Yeah, there you go. Not one, but two. You're absolutely right. because you're not just building one field, you're building two. That's, by the way, the speeds of the disk is a misnomer for the speeds of the field. It's not the same. You see, take the effect that you got going on. Your disk move at one speed, but you're slinging a static field. When you're slinging a static field and it hits the side of something, right, you're going to get it to rotate a little faster. The magnetic field will rotate always in the opposite direction as the static field. The two opposite ends of the same scale, but they always go in opposite directions. Okay? That's what time dilation field's about. Right here. You have two fields going in different directions. As you create plasma in there, it creates a push-off point, so you're amplifying the amount of speed that's going in. So regardless of how fast your disks are going, your energy fields are going faster. That's why we get problems when people go to define this stuff, because they see it as the disk speed, not as the speed of the field. Because if you don't account for the outside field it creates, you can't account for the speed of it, which makes it wrong. So when you look up papers and stuff and they have to deal with this, they may not be talking about the rotational field of the actual disk itself, okay, unless that stuff is sucked into it, which you're creating the wrong field. It may just be that the field is slinging off of it accelerates, and you're going to get a little higher value out of it. So there you go. Yeah, Bob Greenyer did do an amazing disclosure. Bob Greenyer is awesome, by the way. He does all kinds of cool stuff, man. Let's see. I was just watching Bob Greenyer's live stream. He was great. One of the biggest fans. I just bought his Evo Kickstarter book. Nice, very nice. Yeah, dude, the way he breaks that thing down, Charlie, I'm gonna tell you, man, the best in the business about breaking that thing down. I mean, you got to remember, he's generally talking about oh god, the thunderstorm generator, where you have two shells and the shells resonate, right? And there's very specific sizes; they do not change, and they're using resonance to break apart the molecules. But they're sending it through where it goes right through the water that's ionized in there, right? So when you ionize the water, what's it doing? It's giving you an easier molecule break apart, right? So that they're easier to pull apart. You resonate them, okay? Then they tear each other apart and they get back to the single molecule they're in. Now, what do you do to put it back together? He creates resonance frequency in order to restructure these things. So whatever resonance frequency he's using to put them back together is how they reform. And then they go out to the exhaust. It's totally amazing. So yeah, I think everybody agrees, man. The dude's awesome. Yeah. Yeah, there's a lot there, man. A lot there. But if you notice, he's not dealing with any different fields. So let's just get into the whole thing about that. Talking about resonance, we're talking about two frequencies, okay? We're talking about a pulse, okay? We're talking about ionization of the molecules themselves in order to break them apart. That sounds a lot like Hutchinson. I mean, think about it. He's using a Tesla coil, but on the top, he has a little bottle up there that's ionization. He's not letting the energy out. It stays in the little bottle, but on the outside of the bottle, it's like a light. It's creating ionization in the air. He uses a high static field in there as well. He has a high magnetic field that is holding it in because he has so much equipment in the room, or he's in a shipping container at the time and he's using that as the outside field. He's creating the magnetic field. He's creating the static field. He's getting a plasma to break them apart. Okay. He's putting an ionization in there. He's using the longitudinal waves of the Tesla coil themselves once the item itself becomes saturation in the resonance field itself. Now he's able to lift it. There's no difference. We're doing the same thing. You think Alexi didn't put ionization in his craft? Well, those wires hanging over there not touching the plates, ionization. He's got it going on the same thing. We're breaking molecules, man. think organic plasma is similar to QI from QI going in Masters. I think the biological Evo. Well, that makes sense. Well, biology is not much different than the fields that we're talking about. Yeah, can't go into it here because they won't let us. But if you have a lot of iron in your blood, guess what? You can get to, how do I say this? If you can produce a field that gets to the inner side of your body, not the outer side of the body. So MHO or NWO is out. That does the outside of your body. You would need something different. And then you can control the values going on in there. And I don't want to say any more than that, but it's absolutely correct that on the track that you're on. But we'd have to talk off YouTube in order to discuss it, unfortunately. Grab Jr. mentioned that water can be charged in sunlight, and an EVO can be released by using an EMP. Yeah. Or you could basically take, how do I say this? You could take microwaves, put them up in your upper atmosphere, and it'll start to build the outside field around the static electricity, and it'll amplify the energy in there, and you'll get a one of those lightning ball things that he's talking about. That's another way to do it. But yeah, you could do it in water. We showed the water experiments, man, where you get the energy in the water and it has an outside field to it because it's pushing against the water. But then if you go in there and you actually get a field on the outside of that, it's like you said, absolutely possible. You're right. Yeah, that's one way. I'll tell you, there's a more ancient way to do it. And I showed it on my channel once, and I don't think anybody figured it out. But it's on there. To be less hungry. Man, I need that. Yeah. Lately, I've been trying to get over a health problem, and I've been doing well, but I haven't been sticking to a diet because I'm just trying to survive. So, yeah. I don't know that you drink it to get plasmoids. That's sorry, I won't say it. Yeah, you know what? Have you guys ever looked into Gerard Morin? And he had the strawberry, and then he put the strawberry in this field, and he said the sugars were more pronounced and it tasted better. That was interesting, man. That was really interesting when he did that one. Same type of energy we're talking about here. He found that same field. He did it in a different way, though. It's the sun. Yeah, it could be. The poles flipped early. Okay. Well, I don't think we've seen any massive things out there. I mean, we just saw a flood in Texas. Do you think that's part of it? Working on contingency plans. Well, you knew it was coming, right? I mean, if you didn't see it on the Black Pyramidium in Egypt, that Oumuamua, or however you say that, is right on the side of it. It's on the right side of it. You'll see it right on there. It's a precursor for what's going on. The first time that it entered our solar system was the Day of the Dead in Mexico. It was the end of the Mayan calendar. It was a prediction of when it was going to come through. And then we've just seen that another object that's just come through our solar system or is going through it now that's like, 5 times the size of it. And I think what follows that may be something else. It's a precursor to things happening, and it could be tied into the pole shift. But if I'm not mistaken, the sun flips poles more times than that in between the, 22,000 year cycle or something like that. So, you know what I mean? It could be the coincidence that it comes through when that happens. It could be right there. So, nice. Yeah, that thing over there in Texas was horrendous, by the way. That's awful. We all say a little prayer each night for people over there. Hopefully, more people are coming out survivors. Done any experiments with welding equipment? says they make Evos. I've welded, burned my eyeballs a couple times, but no, I haven't done anything like that. Well, I mean, what is an Evo? It's a high electrical charged field. That makes sense that they would come out of there. They probably have gas in there that's creating some of the stuff, the argon that they use in there. Sometimes it's different if you use an aluminum welder or a TIG. The gas is different. So I could see that. I could see that. I've welded before and done a lot of shop stuff, but I haven't done any of that in like 20 years. So probably wouldn't be the greatest at telling you about it. I know that Heliarch on his channel, he's a great welder. He's an instructor on it, by the way. I'll bring that up with him and ask him if he sees that in there. He's, like I said, he's an instructor of it. So, yeah. Yeah, it's huge currents. Not something I want to mess with. If you ever welded and somebody then tells you that we're going to put 1,000,000 amps into your UFO, you kind of got like, oh, it's a bad idea. That's a bad idea. I welded with much fewer amps, and that thing was completely destructive. I didn't want to be around that at all. 1,000,000 of them. No, thank you. No, thank you. I'll take the day off on the day you test that. Yeah, I won't be there. I won't even be in the state probably. I'll let you handle that one on your own. Yeah, no, thank you. Yeah, when you think about it, the math doesn't work out until you localize the bubble, does it? Sure doesn't. Because what do you come up with? You need 1,000,000 volts, 1,000,000 amps. Well, not if you create your own locality, you create your own bubble. Then how much you need? You see, I'm not trying to force the thing against the whole world here. I'm trying to move a little bubble. I'm trying to move this little styrofoam thing that I have in between fields. That's all I'm trying to do. It really comes down to the basic understanding of that. That's all I'm trying to do. And I'm trying to use the field itself in order to match the frequency of that area to move it. That's it. Yeah, that's scary. Man, Phil told us that, man, my butt puckered. I was like, no, thank you. That's incineration. That's like the death penalty right there. You're going into that UFO to die. I don't even think the outside of the craft will do it, because as soon as you start the amperage on that, you bring in heat, right? So what happens? The whole entire thing melts. It's not even going to be a UFO. It's going to be an incineration, man. We're going to implode with just melting. I mean, our face is going to be dripped off to the side. You know what I mean? Everything. And then we're just going to start on fire and combust. Yeah. Don't pass gas in that field. Well, I guess it wouldn't matter at that point, man, because you're going down either way. So nothing you can do there. Nothing you can do there. Wow. With 0 volts, it's not possible. It's just not possible. You can't have 0 volts. In a DC system, it's impossible, because the scale works off of each other like this. In an AC system, you still have to have both. One's the push, and then one's the flow. And you got to have both. AC systems are the most dangerous thing on the earth. I'm going to tell you that right now. They are the worst system you can ever use. Kill you. Those things are bad. Really, really bad. I would never put that in my UFO. Did Bernie tell me about hydrogen transformation he's doing with Jeremiah? He's been keeping it kind of a secret, to be honest with you. I think he wants to present it at what, Tesla Tech? And he mentioned a few little things about it, but not in great detail like we all want. So I think he was waiting to see, you know what I mean? They get to Tesla Tech and show it. But he's been hinting at things, but I haven't seen the full picture yet. I get on a stream with him, I think, tomorrow, if he's available, and we'll talk about it then. Because I wanted to hear about this for a while. And on our last stream, man, my headset went out, so I couldn't hear anything. So Yeah, I know he's doing it though. Yeah, AC's bad, man. No, no, thank you. DC's more predictable. You mentioned it on Green Year's live stream. Nice. Was he in the chat? Because I know he's mentioning and dropping hints on it. And he's really, by the way, if you guys watch his show, he's trying to get up all the money he can to go to Tesla Tech, so they can present that with Jeremiah. They're both really excited about it, man. So I hope he's able to, Charlie. I really do. I think Bernie's got some amazing stuff going on there. I can't afford Tesla Tech this year, man. Just can't. I'm not there. Not in that financial place. So next year, I'm definitely going, and I'm going to ask for a spot to present next year. This year is just not possible. But next year, I will definitely go over there and, you know, I mean, get up on stage and do all that stuff because I'll have a lot of stuff to show, and it'll be pretty awesome. So, by the way, we were doing conversions a while back with the Tesla coil and a motor, right? We're trying to get the motor to spin from the Tesla coil. So I don't know. I think a lot of you put it together how I'm going to get that accomplished. And you saw me put the Tesla coil inside of a Tesla coil, right? And then if you remember back even further, I put a Tesla coil inside of a Tesla coil with 2 rods, okay, at different sizes. And then what I did is I put my hammer up to it. And then as soon as I touched it and pulled it, I pulled out a spark about this long, okay, and it was full white. So what does that tell you? One, it wasn't enough voltage to bring it airborne, but it was enough amperage to turn that thing almost pure white. What does that tell you? It means that I was breaking this Tesla coil into an amperage field instead of just a voltage field. What that means is I'm going to have a lot more amps to push that motor. So I'm going to be able to get it to run longer. All I need to do is install a duty cycle into it. So once I do that, I think I have it. I'm going to have a full conversion, excuse me, from the Tesla coil to the magnetic motor, right? And get them to go. The next step after that is, can I run this thing? Because it's Don Smith all the way is what I'm doing there. Field inside of field inside of field in the coils. Can I get that thing to produce a loop? Can I put a couple capacitors in there, change the duty cycle, and get myself a loop? And if I put a ZVS, it'll give me my duty cycle right there, right? All I need to do is put in the correct amount of capacitors to balance the system at that point, and then I should have it. So, yeah, Don Smith all the way, man. The coil, I didn't even put them in resonance with each other yet. I just did them like that to see if the amperage built, and it did, and it built a lot. So, yeah, kind of a different understanding, man. It all just takes time to get there. Next year, you guys will bring a flying craft to Tesla Tech. Oh, dude, I gotta see that. I gotta see that, man. Gotta see that. I will definitely be there next year for that. I'll sit in the front row, man. I'll have to work tomorrow. Okay. Have a good night, man. Appreciate you coming to hang out with that. Oh, double wall graphene superconductors. Now we're talking. Now we're talking some material science here. Nice. I'm still waiting, man, to see if anybody can produce that rodent coil that I did, where I took the Tesla field and I made it stay on for a while, kept it resonating. Gerald got his on his device to go for a little bit too. Okay, I think we're playing in the same area there. So, yeah, I think it's just about how to wire it up. Maybe put a little bit of a back capacitance on it to balance the system. I think that was what was missing. So, right on. Hey, I wanted to do 2 things real quick. Darren gave an Old Man Builds membership. Darren, you're awesome, brother. I totally appreciate it, man. Thank you for that. Ulysses gave a $5 super sticker. Ulysses, you're just so awesome, brother. Thank you, man. I really do appreciate that, guys. That was in the beginning of the show when I was going over everything. Guys, you guys are totally awesome, man. Totally awesome. If you guys haven't seen it yet, Darren, he ran that Tesla coil. I sold him a Tesla coil. He had the top plastic melt all the way down, man. It was dripping on the inside. Yeah, he put something on there, man, and it got it hot quick. Yeah, it was totally awesome to look at. Probably wasn't awesome to clean, though. So he said he got it working. Right on. Hey, Bernie, you going to give any hints on how you're doing that hydrogen thing over there before Tesla Tech, or you holding that one back? Kind of interested in that. Oh, right on, Charlie. Charlie got the membership. Right on, brother. Appreciate it. You have not watched the latest APAC, but the previous one I talked about warp drives. What do you think about warp drives? It's kind of hard because they're not even recognizing how to create a field bubble right now. So, I mean, the same people that get down on me about creating a field bubble are the same people that say they're going to create a warp drive. And I'm still unsure how they're going to do it if they don't understand how to create the bubble right now. I think they totally exist. Okay. I'm all for the science behind it and how to do it. I don't know that they have the understanding yet to get it completely going. I think they have a mathematical proof. I don't think that they have the engineering to get it done yet. Let's see. You'll have to wait. You'll have to be a Tesla Tech. Thank you, Bernie. At least going to film it for us so that we can watch it. Put it on your show. We actually already demonstrated the procedure 2 years ago on my channel. Now I'm going to have to look it up. All right. I'm going to have to look for that. Let's see. Scalar potential in water cells can even make NO2 if you don't have this energy. No salts. Yeah, keep your secrets. Let's see. It's 2 years old on his channel. Yeah, I think we're all ready to see a fresh version of it, Bernie, is what we're all getting to. So we're looking forward to Test to Take. So watch the replay, Bud. Nice work with him. Your articulation is improved. Okay. Articulating. Right on. Yeah, I'd like to see that warp bubble. They don't have, what is it called? The EW. I don't even know the acronym for it. Basically, where you're able to push the frequency against one side of this thing and be able to move it. They don't even have that figured out yet. I mean, how are they going to do a warp bubble? Did they figure out that there's energy everywhere yet? Or are they still stuck on the model where there's no energy between planets? I think that's kind of a big one, don't you think? If you find out there's energy everywhere, we're going to change the entire calculation because it does. So, do I believe in field lines? It depends how you're defining the field. Fields break out, man. They just build out. That's the way fields do. And then they stop. Do I believe in the building field lines between each other? As you know what I mean? Yeah, I do. Because I've seen it. I've seen it work. And worked, matter of fact, 2 bipolar coils, they work just fine like that. So yeah, I do believe in that. Let's see. Yeah. Yeah, that cap was cool, by the way. Yeah, I agree with that, man. I wish my headphones were working that night. That was the coolest thing, by the way, Bernie. That cap stayed in the same spot, man. And then all those little bubbles shooting off, like little little shots. Is boom, 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 boom. I thought that was cool, man. It died when you unplugged the electricity. Well, that sucks. Yeah, I'm excited, man. Talk about the diamonds and stuff, Bernie. If you're available tomorrow, man, that's totally awesome. I think that rocks, man. Well, let's see. We're going ready. It's coming soon. Ask Christ and Harvey born again and whisper. Right on, man. I have looked at his fields, and I don't think that all the correct words are there. I have looked at his fields. I actually went back and looked at his lectures, okay? Because I went ahead and put them on my little AI things that goes ahead and gives them a voice so that I can hear them. I did all of those, and I ordered his book. So, and I started reading it online. Yes, I did look into his stuff. That's why I tell you, he's missing some stuff in there that he knew, and he didn't put it all in there. What he put in there is how to kill Tesla's effects. Make some kits and some people projects can they I agree with that. Oh, right on, man. Appreciate that, Bernie. Yeah, it's gonna be awesome. He has a big interview on Wednesday with Sheila. So if you don't mind, Bernie, I'd like to lock on with you and just, sit in the background and listen. She's awesome, by the way. She shows the frequency and things and how they build out and how they look in 3 dimensions and stuff like that. Sheila's totally awesome. I know Joe's probably looking forward to that one too, man. She's amazing. So that's awesome that you got her to come on, man. Right on, brother. I appreciate that. Yeah, Sheila does great work, man. Can't say enough good things about her. I actually liked that lady that Alien Scientist had on. I don't remember her name, man, but she was awesome. And she kind of went into the stuff he didn't want to go into, but I thoroughly enjoyed that interview, man, where she started talking about the little satellite things out there, and that you can't get beyond a certain point, and can't get beyond the what was it, the field that builds out from the Earth. There, couldn't get beyond that. She was really awesome too, man. I really like that. I know we cut it off earlier and was kind of upset, but I think she was good too, man. I really like that one. Kind of goes into where I like to go with it. Let's see. Bernie tried to add an electric a magnet to keep the effect going. Maybe a magnetic behind the silver, electric behind the bismuth. Interesting. Yeah, we didn't even talk about that bismuth broken down into the liquid state with water and what it does there. I bet Bernie's got a lot of interesting stuff that goes on there. There you go. Yeah, with Steve on it. Steve from Tesla Tech was on there with that interview as well. That's right. Yeah, Jeremy was not a dude. Jeremy was pissed, by the way. That's what it looked like to the rest of us. Like he was like, I didn't get my say so in this. I wasn't able to rebut anything. You know what I mean? And he was like done. I think honestly, every time I see him on that show, man, if you just handled what was going on and you told him what was going on, he loves looking up the science aspect of it and tell you how the science works. And I think he wasn't able to do that, and it probably kind of irritated him a bit. So I think he's great at that, by the way, looking up everything and showing you what things do. I think he's absolutely awesome in that way. I really do appreciate the fact that he does that. So, and he has Mr. Schmuck on all the time, which we all know him as Admiral Schmuck over here. But yeah, geez, that guy, oh man, calls everybody a schmuck. That guy is great. I mean, no real value to what he says unless you break it down and cut out all the other words and finally figure out what he's talking about. But Yeah, Jack, it's the farty, gets out there and calls everybody the schmuck. Completely hilarious. Oh man, what's going on? Yeah, I think when they get done with all this stuff, man, it's all going to be pretty easy to figure out. We're going to be learning this stuff in what, like high school or less, as soon as they figure this stuff out, because it'll be that easy to understand when it comes to UFO physics. I don't think it'll be that hard. You know what I mean? We'll pick it up right away. I think they underestimate, when you put things into easy words that everybody can understand, everybody gets it. You know what I mean? Show it how it's done, show it how it works in demonstrations. I get it. If you got a flying craft, man, reverse engineering that thing once you have it in hand and see the actual parts that's in it, man, that's when you really start to get to understand things. So, do I think gravity is its own field? No. Gravity's an effect. Gravity's not a field. Gravity is an effect. And it has to do with how scalar is built out and things like that, and the different energy levels and the saturation levels of things, and where the actual fields are. And you can't say that there's no field. You can't say that there's no energy between them. It just doesn't work that way. You have to have all of it. So, yeah. Yeah, well, I think a lot of us are smarter than high school. I'm saying in the future, man. I think kids in the future will catch on to this stuff faster than we ever did. It's like you know what I mean? If they taught you good stuff in school, remember we're sixth grade or something like that, and we all had to go into home ec, and you learned how to bake and you learned how to do other things like that, and you caught on to it and kept it for the rest of your life. I think this is what they're going to be doing the same thing in the future. So not my kids, but maybe not even their kids, but the next generation after that, once you figure this out, yeah, that's what they'll be doing. Let's see, you would say gravity is a dielectric acceleration towards the medium, which means that you're creating the dielectric between the outside barrier of the Earth inwards towards the center of the Earth, which I can completely see that. Flat land is real. As long as you don't say flat Earth, then we'd be suspicious. No, flat earthers here, man. We don't subscribe to flat Earth. We know what airplanes are, and we can fly in them, and we can go around the world. There's no way flat Earth works in that scenario. That's like someone's mind blowing up in the middle of the airplane because they realized that the Earth wasn't flat. No chance of flat Earth here, buddy. I'll go bald before flat Earth becomes a thing again, man. That's not coming back. It's like disco, man. It's pretty much done. Okay, no more time for the Bee Gees. Let's see. Is the dielectric lines from the tension in the connected between the matter and then pulling them together like a rubber band? I hear Ashton say that a lot on his show, like a rubber band. I don't think it's like a rubber band, and it's more like pressure. It's creating a downward pressure, is what it's doing, and it's not because the way the Earth moves and creates the rotational value. By the way, if it only created one value going one way, then you'd go fling out everywhere. It's the second one that creates a time dilation that holds you in place. But it's the saturation between the both of them that you're in that holds you in the place that you are. And it breaks that saturation every once in a while when you see something weird go on. But I think it pulls in towards the center. But I think it's more pressure inside of there. Yeah, it's pulling back into the center, into the ether. I agree with that. No disagreement here. And I think it has to do with which fields you're in, because one's mostly voltage, one's mostly magnetic, right? That's something that Steinman's talked about all the time. Magnetic and the magnetic field and the voltage field, which is basically the amperage field and the voltage field. And that's what Steinman's talked about all the time. So yeah, would it work that way? Yeah. Which way does it flow into? Which way does it want to go into? Well, the static field always tried to go towards the magnetic field. That's the way we all understand it, right? I think you're right there. Topological lines of potential, yes. But you got to remember, energy drops off and it changes form. So it makes perfect sense. So if you're up here, it's a high value of electricity, right? You get down here, it's a high level of magnetism, right? But it's like a DC field in the way it works. As soon as you bring down the frequency, you start going like this, right? And it starts to bring you down. Well, that's what's going on. We're bringing down the frequency right there. So it's bringing up the amperage while it's bringing down the voltage. So we're in that level of saturation on a plane, you know what I mean? That gets saturated. It's like putting the high voltage line, but putting the third wire in there. We're on the third wire, the center wire. We have the two sides here, and we're in the center wire. That's kind of the way I see it. Let's see. So if you want anti-gravity, what you need to do is disconnect all the dielectric lines and tension from your craft. Well, that's what the resonance is for. It takes away all those things. It doesn't allow you to stay in that same area. Because they build out differently. You got to remember that. The magnetic field builds out like this. The dielectric field builds out like that, just like Simon's told you. Okay? So you have to get rid of the both. Okay? You got the field that builds out like this, which is basically your RF lines that build out like this, but you need the longitudinal wave in order to get rid of the little ones that go like this. Okay? So you need the transverse and you need the longitudinal wave to work in resonance together in order to get that out of your way to move it. So I think it's more than just one side of it. It's all dielectric lines of tension between your craft and the earth and preventing it from floating away. Again, I think there's two sides to that, and I think it has to do with both of those fields in conjunction. What I learned about the most recent APAC, I got to see Jared in the most recent one, and he had that chart, and it had to do with all the different things in there. I caught that part of it. That's the part that I caught of it. And I thought it was fascinating on the materials that he's working with in order to figure this stuff out. I just wish he made the transistor connection on it and how they work together. I think it would really advance what he's doing, especially since they're sending everything off to labs and see what it does. You know what I mean? What things they are. I did not catch the rest of it yet. I haven't had time. I've been super busy in here trying to get my whole area repainted. So that's the part that I did catch. Let's see. Gravity is a depressurization of the ether. We know that it creates a pressure. And remember that, so depressurization makes a lot of sense in that way. Of the ether, I guess if you consider the entire planet built out as the ether, yes, that I see. So it needs to measure what happens in the gap between the rubber band and the flywheel. Yeah, let somebody else tackle that one. I don't have that whole analogy of the rubber band really understood that well. I'll be honest with you. I don't subscribe to a ton of analogies. I didn't understand that one yet. We'll watch it afterwards. Right on, man. Oh man, looking forward to the nature's transistors. Well, look at their nest. Just look at their nest. What are they building in their nest? Why is it putting out resonance? Why are they using each one of the different things that they're doing? Think about it. The cone structure, is it really just a honeycomb structure, or is it a horn structure as well? Is it built out smaller in the back of it and built out? I mean, start thinking about these kind of things as you're looking at it. The structures matter and how they get the effect that they're getting. It's like a bunch of different horns in there going off of a resonance, and they have this diaphragm that's moving. They're attracted to that. Just describing any captivation effect, decompression of the ether. Hey, what's up, Joe? Right on, man. Let's see, trees are a version of it as well. I was watching something on that about how the trees work and how their water goes through it and how it wants to reach up, and then how the roots want to reach down. You know what I mean? Like the tree limbs always want to go up to the voltage area of the field, right, and get bigger, and then the roots always want to go down towards the magnetic. And what was cool about that is they showed it. If you take a ceramic magnet, say from a magnetron, and you basically put it in the dirt, you put a seed in there, it'll grow 4 times faster than your conventional seed will, and you'll get a better effect out of it. That could be the same type of thing that's going on with trees. So it was interesting to see how that worked. Yeah, 100 feet up. Yeah. What's going on, Lulu? How's everything going? Yeah, well, it's colder up there, so it's getting more moisture. Yeah, it's like reaching for water up in the sky, huh? That'd be interesting. Electroculture, love that stuff, man. You made a electroculture spiral today. Nice. You speak. Oh, so you did. Okay, there you go. There you go. Well, you're also working with the same fields that I am, basically. So when you get your seeds in there, man, they're going to sprout better. They're going to grow faster. You know what I mean? Yeah, you're going to have a whole bunch of different effects in there if you continuously run this stuff, man. It's not harmful to run this kind of stuff, man. You just have to understand at what value you have to keep it at in order to keep it out of the harmful level. Run it real low, man, as low as you possibly can and get it to go. You're grounding out when you put it into dirt, by the way, you're grounding out the volts and amps, and you're allowing the frequency to propagate through it. So think about what I just said for a minute. What test did I do that showed that? When you put the energy into mud and you light up your light bulb above it, okay, on the dirt clod, then you put your hand onto it and it turns out the light. What's going on there? You're grounding out the voltage and amperage into the mud. The frequency has a direct line to you, but it's not the skin effect. You're in the wrong side. I'll leave it at that. Let's see. You have a theory that says that Tesla coils produces the red shift, the spark gap produces the blue shift. The red shift allowed you is used below the UFO to push it up, and the blue shift of the red to pull it forward to warp. So when you say red shift and blue shift, right? I'm sure that's a physics term on how that works out there. But you have your magnetic and static fields, and you use voltage as your direction because the frequency is going to become your direction in each one of them, and it should shoot, and you create a bowl-like structure underneath it, which means it's the bottom half of the field where the magnetics are. At least that's the way I understood it. Oh, isn't it just Oh man, you got a whole big word there. I'm not even trying to say that. Are you trying to say body capacitance? No. There you go. That makes more sense. Yeah. No, it's not. Eh, I can't tell you what it does. I can tell you what it does, but the YouTube will let me. Let's just say it's the opposite effect of the NWO machine. It works on a different part. That's about as far as I'm willing to say it goes. But yeah, it's doing something else. Let's see. Yeah. So here's the thing, Charlie. I'd say it like this: we always look for the magnetic field for a double jump. So when you have a sufficient magnetic field underneath something, and then you have a little coil on top, right? And you can get it to jump. You change the frequency in that on the second part. Say they're bifilar coil, right? It'll jump again. Okay. Now just understand this. Does it work when you remove the magnet then? Are you still in that same bubble? Because you've jumped it based on the magnet being here and you've jumped it. Now you turn on the other coil and you jumped it again. What's the next level of that? You see, now you have a secondary bubble sitting on top of the first bubble, okay, which was produced by the magnetic field when you started, but then the magnetic field was gone by the time you get to this one. This is something Gerald showed on his channel with his two little coils there. It's an understanding of anti-gravity. He's literally moving in between the field bubbles. So we always look for the double jump when it comes to the magnetic field on the bottom. Are you getting that double jump out of it? Can it create a base to jump the second time? Can you get that bubble to go like this? You get it to go like this. Can you stack? Can you keep stacking? Just like your levitation experiment. Can you take that little styrofoam ball and move it to the next one up? You move it to the next one up after that. Or the next one up after that. What is it going to take? If you pick a piezo and put it in the center, right? And you turn it on and you got this thing to work. Can you put the pressure on it with the piezo where it sits, take the pressure off and will it jump? Can you do it again? You do it again. Those are the questions you need to be asking in that field. That's part of anti-gravity right there, is that little bubble underneath it. That's that bowl that they talk about. What happens to a capacitor when the energy goes into it? That's what you got to ask yourself. Think about it. You obviously have voltage and you have amperage, right? You also have frequency. You always have frequency with it. Okay, or else you couldn't have voltage and amperage. So the question is, once you ground out the voltage and amperage, what happens to frequency? It doesn't just dissipate. It's not working in that way. So let's see, for your motor runtime, maybe rail above, you can see the caps set up in parallel. By the way, I'm getting a ton more amps than I did the first time I ran that test. So the second time is going to be telling. So I could time it on the first time I ran that test with the Tesla coil of the motor and see how long it lasted. Before I put in anything else, I just want to see if I can get it up to a minute. If I can get it to go to a minute, I think I have it. I think I could duty cycle that one out. But I have to run for a minute. I think I got, a couple seconds out of it last time, and that's not going to cut it. I have right now 3 Tesla coils that are nested inside of each other, right? So you have the main one on the outside, you have one that goes on the inside, and another one that goes on the inside of that. Then I have the actual rods that I put down in. Now, I am literally not lying to you when I'm saying this. I'm pulling down the frequency of the original Tesla coil in order to create more amperage in the field. I'm converting. You know, when you get to original Tesla coil and how it works, you're converting amperage to voltage, right? Well, I'm taking it in the opposite direction. I am converting back to amperage. So it's the conversion from I know I'm in this field, I know I want to be in this field, that's the way I need to do it. So I also have some faster diodes instead of the ones I had before. And I have smaller caps. So like a 400-volt cap that's a real small one like this instead of that big giant blue one. I got a bunch of smaller ones. So I think we'll do better in that side. And then if I can match whatever frequency comes out of the main one, okay, and I can isolate that frequency, then I can match it on the backside with capacitance. It's the same frequency in order for the energy to flow better. So just do a balancing act, right? In order to get it to flow better. So that way I don't have any energy losses until I get to that part past the capacitor where I wanted the energy to have kind of a loss in it. That's where you want to back it up a little bit. Even a resistor at that point might work, right? Because it backs up the heat level, it's just backing up into the capacitor, which it won't go up in there because there's too much pressure in the line. But it'll do it enough to give it like a duty cycle, depending on what value you put there. Maybe I put a potentiometer in there in order to create just a little bit of a timing in there so that I can get that thing to burst instead of going. So it's like as soon as the motor starts running, if I just hit it at the high point, okay, at the point where it just needs to push, just like resonance when you're pushing somebody on a swing, right? They get to the top, give them that little push, okay? It's just it. Same thing. That's all I want to do there. If I can pull that off, then we'll have that motor running all day long. Because once you get past a certain point, it's all about can you get that to that point? When do you need to add the amount of energy? When you need to slow it? And by the way, we got that from Tim from Timtron channel and Heliarch. Okay, both of them came on the show. Absolutely awesome people, by the way. And if you want to learn about over unity in those kind of systems, including the Meg, to check them out, get on their Patreon, hook up with them, and talk to them. Those guys are amazing. But we got that directly from them on how to do that. That right there was the conversion I needed to understand in order to get that motor to run properly. And I think he knew it. So when I showed that experiment, he mentioned something on it. I think he was looking for it. He knew I was getting there. He knew I wasn't there yet. So, yeah, those guys are brilliant, by the way. So if you need help on one of those machines, they have the answer for you. It's well worth their money to get on their Patreon and talk with them about it. And they're really good people. So let's see. Would it be, I think, the no magnetic effect happening? Good question. Any magnetic anomalies? Not sure which one we're talking about. If you're talking about the rod down the center, there's that magnetic field is reduced down to a very tiny amount. So you're mostly getting the radiant value of it, the amount that builds out without that field and without the electric field. So no, you wouldn't get it in there. If you're flipping the field with the coil inside of a coil inside of a coil inside of a coil, you absolutely get a magnetic value out of it. And it'll change the amperage level. That's why bringing down the frequency and bringing up the amperage in your coil is what it'll do. And you'll start to produce a magnetic field out of it. That's exactly what it's doing. So you've got to capture that energy before it goes to a major magnetic moment where it overwhelms the whole system. You have to be able to pull that energy out before it does that. Yes, he did. Two frequencies and he resonate with each other and a pulsed. Dr. Rife, MWO machine. Absolutely. Love that, by the way. When they talk about it, there's not a whole lot of great sources that talk about it on the internet. And the ones they have, they abbreviate everything and can't get to the point. I think YouTube won't let them, but that guy was absolutely brilliant. Yeah, watch wall. There it is. I'll drop a link for a Heliarch channel. I'll do that. I don't have their. He'll connect you to it. It's in his description, I believe, of any one of his videos. There you go. There's our channel right there. Like I said, just contact him, man, and he'll get back to you. And like I said, get on and talk with him a little bit. Make sure your project's up to where it needs to be, and then boom. Yeah, I mean, hook up. He'll give you all the instructions you need. Great guys, man. Really super smart, man. Let's see. I have no idea if you can do that or not. I've never tried. Let's see. Have you jumped? Excuse me. Have you joined Bob Green's Evil Labs? I have not. I have not. I rarely have any time these days. So it would be interesting to do it though. Let's see. Cross product of two fields in the magnetic right. Imagine the fields in the solenoid. Well, imagine what happens when you're building out these frequencies and you start to get them in resonance with each other. So far, I have nothing in resonance. If I started to put in resonance, what happens when I start running the Casimir effect in the center? Start to think about that. And then you have resonant fields going on. What does that do? So you want to mess with somebody, you want to create a crowd control device, you want to create something more powerful than that. That's the direction you go. It's also, we were looking at, Sean and I were looking at the bipolar Tesla coil, and we were also looking at a thruster from plasma channel, right? I built one of those a while back. And the interesting part about it is it worked in AC and DC fields, and it did in both, right? And when you get to a bipolar Tesla coil, this is kind of interesting, where you put the primary on it, you can adjust that thing back and forth, right? And get different values out of it. So you can go from a magnetic to a static field and start building the amount of energy in it. But what happens when you take that Tesla coil and it's bipolar and you wrap it like Sean does, and you make it like an AC flyback in there now, and you wind it in that with field after field after field after field, right? So it would be the same thing, except for you get massive amounts of changes in the energy. Now, just understand it like this. They talked about the fields that goes into one of these thruster devices, and they have those rings in there, right? You got like 5 different rings, and they all have a different part that has to play with the ion wind as you shove it through this device. It's kind of the same thing, except for using a bipolar Tesla coil in order to get you there. And you can use multiple ones in conjunction in order to do this. You're not just taking the same field and the same field, by understanding that if you create different frequencies in each one that you use, you can create different levels that will add up way faster. So total different concept to how you do this thing. You can have more than one primary on it, which just basically means that's the value it's reading at the time, and it's able to push more into that coil. A second primary, can you get it to work? Can you get a field that pulls out of it? It's an interesting concept in itself to make a thruster that has way more power. 2.4 meters per second is nothing compared to what this thing should be able to put out if you understand it correctly. So yeah, a whole different way to look at these thrusters, man. Can you make something that works out in space a lot more efficiently than putting gas to it? Maybe there's a way you can just do an electrical value, then we don't have a problem out there. Because once you get moving in space, the hardest thing to do is put on the brakes. So yeah, it might be a lot easier, right? That's it. You made one but couldn't get it to work on the ZVS. So I did it. Okay. I'll say this. We did it at a DC field, so I took 2 DC flybacks, put them one to the next, right? And so you did negative on one side, positive into the negative of the other, and then positive out the other side. You hooked them both into your ZVS, and it got it going, right, with the ZVS between the two of them, because you're just looking at an oscillation between the two when it turns on the magnetic value of each one of them, right? That's all you're doing there. So that one worked out, and that was able, like I said, 2.4 meters per second at about, I think it was 1.5 inches, which was pretty much common to what I got when I did any kind of ion wind. When I did it in the voltage multiplier, it was much different understanding of how it worked. Okay. I had a 4-inch spark that came out of this thing, and it had to do with how much of the metal I can magnetize before it was able to push out the field. And the distance between the saw blade and where the actual coil was around it changed in itself based on that. So there was a different understanding of wind in that one altogether, but I was still able to produce the ion wind in there. And that was the same thing that plasma channel used. So ZVS, it depends on what you're driving with it. It's never going to do it by itself. It just can't. It doesn't have the values, and it doesn't bring things to the extreme. It doesn't bring things to one magnetic and then one static level, right? It doesn't change that. The ZVS doesn't. The ZVS is a magnetic pulse. Just turns it on and off, on and off, on and off, right? So when you put your capacitors in there, you're changing the value of your magnetic pulse is what you're doing. You're getting it to go fire faster or less to match the same amount that's in your primary number 1 coil of your tester coil. So let's see how the test of the hairpin produces significant amps to light a bulb. Interesting, because it works a lot like the energy I'm working with. It's the same thing. It produces energy to light a light bulb, but you got to, if you're looking at a thruster, you're looking at ion wind, and you got to be able to take ion wind and then multiply it through the different levels of it, right? You can't just do it on one level. One level gets you nowhere. The AC is more of a better understanding of that because you're able to add them together. DC you can't add together. They don't work that way. I don't know that way would do it. Because when you're doing that kind of thing and you're working with that type of energy, you're working with water, you're working with things like that. You're not necessarily working with thrust. So I'm not sure if that would do it. But if you have a video on how it did it, then that would be amazing. I'd definitely show it. But I haven't figured out a way to make that work at all. Not unless you made the field hot. Then if you made the field hot, what's the point of putting the rod down the center? Right on, brother. Yeah, not with DC. It just doesn't multiply that way. It doesn't add out. It doesn't put one to the next and the next. It doesn't. AC does it. But that voltage multiplier does it. The little spark units, the little what's it called? Taser modules, they do it. But they're highly inconsistent on the spark over rate. So they're not as great there. Man, you would need a high K value capacitor, which would be really nice for something like that. Some kind of electric that does a high value K value in the capacitance. Drive it with that, get that up to the speed. Then I bet you can get a lot more force driven because now you're working with the right stuff. Because it's based on the bottom side is the magnetic field that goes in. The top side is more the static field. The static field tracks always to the magnetic side of it. Just like Toymaker was trying to say earlier, that's the way the flow direction always goes. So when you can amplify one without losing distance, so you don't put a bigger gap in it because the bigger gap just, doesn't give you that much force. I've seen them where they got it up to this far apart and then get it to go, but it's the ion wind isn't that great. It kind of loses its luster by the time it gets there, if you know what I mean. Those are better for flipping fields. If you get something like that on voltage multiplier, now you're talking a field flip. And I've seen that plenty of times where you can start to carry weight on the bottom and it outmatches the top and it starts to lift. And I think people think it's ion wind still. It's not. Ion wind is basically that side in every single lifter. You get the triangle on the side, and the airflow goes through, right? And based on the amount of weight of this thing, it'll lift. How much pressure can you put against the weight, right? Well, the other kind of lifter is completely different. You have a flat plate, you have no sides, okay? You just have a flat plate on the bottom, and you have the wire on the top. And you take this thing that's got that, 5, 6 inch spark that comes out of it, out of that AC, and you push it down, and over that area that it's in, that part there cancels out. But the rest of it is so energized, it's only pushing one direction. It's a whole different understanding of how a lift works than that. Oh, let's see. You know how to nanocoat layer encoding charge directions and polarizations. I do believe that. Nanocoating is going to be awesome, Bernie. Telling you this right now, man, with that Ormus that you do, man, if we can frequency the structure of it, or you can frequency the structure of it, and that's what you're getting your nanocoating from, and you're able to add a real good mesh structure to it. Oh my God, dude, that's off the charts. Yeah, off the charts, dude, on what you're going to be able to do. I can't explain to you how big of a physics step that is. It's like going from a core processor to like a Ryzen 9. It's just like boom. You know what I mean? It's like, what happened here? That's the kind of level you're getting into. Vapor deposition. Nice. It's not technologically Ormus. Well, that's what Bernie calls it, so I'm going to continue to call it that. Did you find the difference in performance while connecting pure earth wire to ground versus the electric socket earth to ground? Any Tesla circuits? Okay. How do I want to say this? There's a difference in the way your battery works in the chemical values versus the socket. There's those two things. There's also a difference in understanding and values when you pull energy from the earth. So let's just look at the two. And this is the way I take the question. So if I'm on the wrong area, just let me know. But the actual chemicals in the battery are different, so they react in a different way when you push back on them. Okay. So the amperage is much better when you do it. And in the wall socket, you can adjust for that, but you're only going based on what the amperage is for that particular circuit, right? But in the battery, it gets a very high amperage field, so you can manipulate that in order to change value. But you can also manipulate the electric field using PNPs in order to change the values and everything and get a higher electric value out of it. Now, how it actually refills and goes like that, it'll start to convert your battery like a Bedini battery. That's what I noticed. You start to have different things going on in it. That's how you know you're converting things well. Wall socket doesn't do that. It's pretty much a fire hose, an uncontrollable fire hose that you cannot compensate for. It's hard to deal with unless you really understand it as a fire hose. Okay. Well, that's why I say you don't put your foot off the gas. You haven't taken the, you know what I mean? You haven't turned off the spigot. It's still flowing no matter what you're doing. When we talk about the energy of the earth and Tesla, the energy comes in from the atmosphere and goes down towards the magnetic value. So, I mean, Toymaker pretty much told you the same thing I've been telling you about the Tesla Tower, okay, the Wardenclyffe. You're pulling in the energy from the atmosphere, you're bringing it down to the energy that was put in the water table. The water table pushes out the energy, works like a scalar does. So it'll build out a field around it, and then it'll look like a null zone. But it's not a null zone, it's a massive energy zone. Okay, we just aren't at the ability to tap into that right then and there. And unless you erect a tower in between it, then you can tap into it. But then it builds out until you get to the next one. And the next one will build out in that same scalar field. That's why there's a difference. That's like a Bearden scalar field versus the conventional mathematical version of a scalar field. They're different in that way. Okay. We're going into what would be the, oh man, getting into the Planck scale, which just means it's compressing the energy inside that little RF field that's pretty much a radiant field because it's so far pushed together that it's putting it in there and it's putting out a beam of energy that goes across it. Now, this isn't harmful to anything that goes through it, but when you contact that beam and set up a tower on there in the correct frequency, you get the full force of that. So you want to be just out of resonance level so that you're not getting that. That's the understanding of what's going on there. We're in craft, when you put them on the ground, you're pumping the energy in, but you're pumping in the energy of the earth itself. However the earth made it, you're getting it. Okay. That's what you're doing. You're drawing it in. It's like sucking on your straw, okay, to the earth. And it's energy based. So you're sucking on your straw to the earth. The energy from the earth is pulling into the thing, right? That's what you're getting in your mouth. You're all, oh man, it's dirt. Well, yeah, it's the energy field of the earth, though. It's energy. You're pulling that in your craft. So that also happens. Can you put it in a capacitor? Well, sure you can. I mean, we do it all day long. We make earth batteries and we run corona motors. This isn't out of the line of physics of what we're going to because it's already proven that both work. All you're doing is changing the level of capacitance between them with two plates. Put a plate in the center, that's your pull out. That's where you're able to take the energy out. Take the top plate, that's going to give you voltage, this is going to give you amperage. You put them together, and the saturation layer in between them is what you're going to pull out. That's going to have a voltage and amperage and a frequency to it, which is able to convert into capacitors into energy you can use normally. Seemed pretty easy to me. And by the way, we saw Inventor 3 do that. He was pulling the energy from the earth into that Tesla coil by putting it over the rod that went into the ground. We also saw him have a big antenna, and he was pulling the energy into there. He showed it going into the capacitor bank, so he showed you be able to pull it together. He also showed you how the three plates work. When you have the plate in the center and gets saturated by the top and bottom, it doesn't see them as different energies. It just sees them as energy. See, that's what people don't really understand. If you want to pull this thing, you go, how do I combine a amperage field and a voltage field, right? How do I get that done? Well, use that capacitor. Use that three-plate capacitor right there. I always talk about it in three prongs, okay? You have the one you're pulling out, and you have the two that are saturating each one. The saturations overlap each other, like, I don't know if you can see it, like that. And then the plate's right here, and it pulls in all the energy. Sorry, that was probably a very bad representation by my hands. But yes, you could do it. So if you want to use, what was that thing called? The homopolar generator, was just basically a magnet where you put the wire onto the magnet and it gave you an amperage field. Then you want to use a Tesla coil and you want to be able to pull out the full voltage of something without any amperage. Then you have to have them saturate both into a center plate so that you can pull out that energy in the center of it in order to make it work for you with voltage and amperage. So yeah, there is a way to do that. Let's see. Ground is interesting, yes. Let's see. Brent calls enormous gains of monatomic and nanolattice layer field. Yeah, I know that word, direction particles, aka spintronics and magneto optronics. Wow, that's a lot of words. That's a mouthful. Got it. Copper disc. Well, which value do you want? Do you want the, if you talk about electrons stick to copper more than they do the aluminum. Aluminum has eddy current, so it forces the fields outside of it. So if you use copper in that center one, it's not going to give you the same value, okay? Or it'll suck it in, a lot better, but you want on the outside fields, you want aluminum. The aluminum pushes off with eddy currents as soon as it hits a magnetic value and forces the energy to build the field bigger, right? That's kind of one of the effects when you want to go with the aluminum there. The actual copper will pull in the energy a lot better. There's other materials you can use to do that, but yeah, those are what you want to do. But you also have to have the plates. You spray them with lacquer for clear lacquer, whatever, right? You want no sparking going on at all. You don't want any sparking. You want that tension of that field is what you're looking for. You want no sparking. Okay. You want to spray the living daylights out of those sides of those plates. And then, you know what I mean? Get that thing to not spark over whatsoever. I would do mostly the aluminum sides on both the top and bottom, keep them aluminum, spray the aluminum, leave the copper how it is plain, and see how it works, right? You could use aluminum in the center as well, but you might get a better value out of using copper in that area since it's used to pulling in the electron value. Or you can get something that pulls in even better and use it. So you're notifying us for mini and this call winding projects. I'm not sure what that is. A caduceus coil? I probably ran across it, but I'm not sure which one you're talking about. Yeah, you asked it again. I'm not sure. When you say caduceus, is that geometry coils? Is it? I don't know what it is. I'm sorry. I probably seen it. I have no idea which one you're talking about. So if you run one of those generators and the homopole generator, I think it's Faraday who ran that thing, and you get a high amperage field out of it, right? And then, oh man, I can't think of the guy's name. He used mercury on both sides in order to pick up the amperage field into it, right? And he was going to convert and add the voltage field to it. And I think he did it in the liquid of the mercury, which gave it a easier way to put both together. I like the air capacitor idea and the way that works a little bit better, only because it gives you a better understanding before you move on to something else. Because there's a lot more variables that can go wrong in mercury. That and it's just not safe to be around when you start putting a bunch of voltage through it or amperage. But yeah, I like the capacitors a lot better. Yeah, you got a lot of amperage, ton of amperage. Twisted like a snake. Joe was talking about this very thing, like a braiding kind of thing or stuff like that. I've never messed with them, to be honest with you. So I wouldn't be able to tell you accurately how they work at all. I know Joe talks about a lot. Yeah, it's kind of like what I'm talking about. It's yeah, I've never done that. I know Joe and Ian were talking about that kind of stuff, but I haven't gotten really far into it, to be very honest with you. Yeah, like the doctor symbol, like a braiding. Like I said, I haven't gotten into that. Uh, vertical. Yeah. Sorry, guys. No, I'm not too up to date on that one. I kind of have a few projects I've been working on, but I haven't figured that one out yet. Um, I know that I created one that's no, I shouldn't even say it's like it. It's not. It was a Jacob's ladder, but it was built, you know what I mean, circling each other like this, which is really cool, but not doing the same thing you guys are doing. Not in any way. So yeah, I don't have a great answer for you on that one at all. Sorry about that. I'll have to look more into it. Oh man. Fun to watch. Oh yeah, that was fun to watch, man, when that did that. So by the way, I just want to go over some of the shorts, guys, before we take off that I did. And I was using different light bulbs, and I have to make a correction, and I should probably put it on the video. The two light bulbs that I used in the experiments, I thought they were regular light bulbs. They weren't. They were LEDs. So the field itself still pulled out a huge, brightness to it, but they were actually LEDs. So just understand that when you guys look at it, which means the cool thing is the coil inside of a coil, you can put an LED light in there all day. And you do it the right way, you can get bright and really cool effects because it makes some awesome LED lights. Just for people out there, I did take 200-watt light bulbs and lit them up in there in the other experiments, which you actually saw the filament in there. I should have gotten lesser values because I probably would have seen that filament heat up, but there wasn't enough energy in there to heat up the filament for 200 watts. So it kind of gives you a kind of description and where it was. Yeah. Double helical, Nathan. I know. Look, I'm sorry. I'm not there, man. Maybe I'm just drawing a blank. I think Joe would be better at this discussion than I am on that particular coil, to be very honest with you. Because he likes everybody to have complicated windings when they do stuff. And I think that was one of the ones he was talking about. One of the ones I said absolutely no to. Huh. Oh, nice. Yeah, those a lot of work, huh, Bernie? Yeah. Not yeah, done enough work, man. You don't know how much my eyeballs hurt. So you guys know, I wind those coils, and I have to wear my wife's glasses. So there's little tiny glasses, right? And I look like Chuck Schumer because they're down on the bridge of my nose, and I'm looking down, man, like an old man, right? And I look like Santa Claus out there, man, without the red suit, which is even more horrifying. And I'm looking down at these little tiny coils trying to match a lineup, and it absolutely sucks. I couldn't imagine braiding these things or turning them inside out and creating hooks that cover. No way. No way. Not unless it was big wire and it was easy to maneuver. No way in what I do would I be able to do that. I have trouble with the little wire as it is, man. Getting old. Uh Making some new coils. Right on, Bernie. Any special metals you're putting in these ones? Have you put I asked you a question on email, maybe you can answer. Have you used pure common, pure carbon, or like any type of carbon as your sacrificial? I don't remember if it's anode or cathode, but have you done that one? Kind of interested to see. Flat bifilar cancels the magnetic field. If you have them right on top of each other and you don't pull the dielectric apart, you're right. If it's two speaker wires connected to each other, you get no value in between, which means it's a worthless coil. It's it it. Mm, there's no particular great value there. It's like the after effects. It's like the morning after kind of thing, man. You're searching for something you had last night and you ain't got it. Um, you need to pull the coils apart. In between them is where the action is. Right on. Yeah, we'll bring it up with Joe's on Friday, man. We'll talk about. Nice. Literally what he just made the sacrificial candidate iron welding rod coated in carbon with aluminum and copper solenoids added on, not, or solenoids. Sorry. add it on. Right on, brother. That's what I want to see. If we can, I don't do these experiments, Bernie does. If he can capture that carbon as that material, I'd be interesting to see if we can get him some kind of a frequency geometry. You know what I mean? Like a resonance chamber. Keeps going around and around and around. See if we can't restructure that. That would be awesome. And just put it in water and restructure. I have a feeling you're going to find it. So what does that basically mean? It means take your frequency generator and it's got a pulse the same frequency consistently over and over and over and over and over and over again. That's what you got to look for. I wonder if that's all it's doing when we put the salt in there and it builds bigger crystals, then you get that pulse frequency over and over again. Yeah. Yeah, as soon as you get the graphene on it, then with large scale hydrogen isotope production. Nice. Well, that's what I'm saying. Those true bifilar coils. How do I say this? You're canceling out one of the fields when they attach to each other. That's the problem. And it's producing the other field effect. That's what it's doing. You're canceling out the voltage field, you're building the magnetic field. And that's what I've noticed. So if you want to put a magnet on top of it, get it to spin, you can do it all day long. If you want to do something that has something to do with some kind of voltage, it's worthless. It's not worth the time. Single wire each one of them. You use them as your capacitor. You're not canceling anything out. Yeah, it'd be side by side. That's what I said. Instead of up and down like this, like your speaker wire is, they're like this, side by side. That's what we're talking about. Same thing. That's what Tesla did. There's a guy on the internet really good at those things right there, and he shows you the difference when you push them in and pull them out, and the field that's going on in there, and how he lights up light bulbs and stuff inside that field. Okay, he shows you exactly what they're doing. Nice. Getting old man builds. I don't know what that was about. Oh, check it out. So they shipped me this already. I have my coffee mug now, my old man builds coffee mug with my little Tesla coil there. And yes, it's actually a Tesla coil, which I don't think Bernie agrees with, but it actually is, man. So I ordered that, and then I got 3 shirts coming in, so that I can wear them. So I can wear them on the show when I do them, man. So I'll buy a couple more, but yeah. Yeah, you can say it is, man. I 100% guarantee you, man, that it's a picture of my testicle, although we'll put it up there again. You can see the windings on the bottom, and you can, I won't deny what it looks like, okay, to everybody else, but yeah. Yeah, I bet everybody thinks, man, by the time I get on here and start talking, that's what I'm doing. But I'm telling you, I'm not. But that's absolutely hilarious, though. Oh, it gets dirty with you. You're intended to drink the water that's in that cup, though. That's the difference. Oh, Tesla's purple plate is real. I've seen it on on people's channels, but I have no idea. That's pretty cool if it is. Oh yeah. Get you high drinking your coffee cup. Well, not this one. This one will just keep you awake. Oh, let's see. True field interaction requires coherence. Flat coil speak, bipolar coil listen, EM coil shout. Okay. Oh man, wire. It just gave you a spark. Nice. Yeah, man. Just so you guys know, we got the shorts there. I'll show you guys. So we got some cool ones on there, man. The old man build stuff. Go to the big layout in this. Awesome designs, man. Just for Mike out there, we wanted to make sure that we all knew there are 3 holes. So yeah, you can pick up that shirt, man. I'll never forget that conversation. Him and Ben, man, best ever. So, and then we have out there Make Ether Great Again. It doesn't come in red, unfortunately, but pretty cool. And we got Joe rocking it out. Things with men, things don't do that. Oh, it's awesome. That's just 3 holes. That's my favorite, dude. So, and then these, Joe designed these right here. See, that's a mouse pad, man. Old Man Builds Garage Anti-Gravity Research Center. That's cool. Another one like it, man. Joe's awesome at this, by the way. So, there's a Gravity Flyer one. And there's me and my bong, or excuse me, my Tesla coil. So, anyway, pretty fun, guys. Oh, man. Yeah, it's cool stuff, guys. You got it over there. I have the link in the description of this video. I'll go ahead and leave this one as well. I'll put it in right now for you guys. If you guys head over there and want to buy something, man, totally awesome. Support the channel. Allow me to build more cool stuff. Yeah. Yeah, so far Joe is the best seller. I think he had the inside track on that one though. But I'm, you know what I mean? The other ones are catching up. Anyway, guys, hey, I want to say thank you for everybody for hanging out with me, man. It's about 3 hours. I'm about done for the day. Look for a stream for tomorrow for me and Bernie. Hopefully we get out there and get some cool stuff done. And then he's got Sheila coming up on Wednesday. So check out Crypto's channel for Wednesday, man. Totally awesome. And if you let me stream on it, it'll be on my channel as well. But yeah, I'm definitely looking forward to Sheila and then tomorrow with Bernie if things work out. Totally awesome stream, man. Looking forward to see what he came up with what he was just telling us he worked on. That'd be cool to take a look at, man. Anyway, man, thank you guys very much for hanging out with me. If you can help Joe go mining, man, the link is in the description of the video. With that said, have yourselves a great day, man.
The old man will. The old man will. The old man builds. The old man builds.
The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds.
The old man builds.
Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend.
The old man builds. The old man builds. The old man builds. The old man builds.
Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend.
The old man builds. The old man builds. The old man builds. The old man builds.
Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend.
The old man builds.